Anand Dixit,
Yeah, hi, I am here.
Ankur Srivastava.
Yeah, hi, ma'am.
Hi. Arvind, Arvind, are you there? Ashish,
Yeah, hi Shivika.
Ashutosh,
Yes, I'm in.
Cheryl, Cheryl, are you there? Harsh,
Yeah, you can say.
Karthik, Poonam,
Yes, Shivika, present.
Ravi, Rilesh, Rushikesh,
Yes, I'm there.
Rutuja,
Yes, I'm there.
Shubham, Sidesh, Sidesh, are you there? Tina,
Yeah, hi.
Vaibhav, Prateek,
Hi, Shivika, I'm here.
Dharini.
Yeah, hi, Shivika, I'm there.
I'll just call out the absentees. Let me know if anybody has joined later. Aboli, Arvind,
I see her on call. Apoli probably.
is there on the call, but I think there is a audio issue. Cheryl,
Hi, Shivika.
hi. Karthik, Ravi, Shubham,
Hi, Shivika, I'm here.
Sidesh, Vaibhav, okay, so we can start. Shrikant, we can start the session. Thank you.
Sure. Thanks, Shivika. Good morning, everyone.
Good morning.
All right. So, are you done with your consumer? Are you able to consume messages produced from your simple producer? Everyone?
Yeah.
Okay, cool. So let me share my screen. Okay. Give me 2 minutes. Are you able to see my screen?
Yes.
Okay. So did you get this project? Kindly download this project and open in your IntelliJ. Okay. Now,
But after downloading this one, we have to try in our local only, right? We won't be able to take this in the.
directly open in your lab. There's a browser, right? So open, take that link and open in your, labs browser. So you don't have to upload from your local to your lab.
Okay. Can you ping that link again, please, in the chat?
All right. Give me 2 minutes. It's a different account. Yeah, just check that.
So we need to take that Avro serializer, T serializer, right?
JSON one.
JSON.
Rishika, in 2 minutes, I'm just starting my lab.
Sure. Let me know, guys, once you're ready. Okay, so you can open this in a IntelliJ. It's an IntelliJ project. So if you point to that folder, you should see a proper folder structure there. Okay, and then I'll explain you, and then first understand, and then you can work on that small exercise there.
Which one we should take? JSON server.
JSON one, yeah. For Avro, you will require a Confluent Kafka. Okay, so I'm sharing that folder as well. So make sure you download everything from that folder which I'm sharing with you. But that can be done later on. Okay, I'll explain you what needs to be done with the Avro as well.
the link that you shared, are we supposed to open in under the lab or?
Under the lab.
Okay.
So you don't have to use any FTP tool to upload it from local to your lab. Directly you can open in a lab.
Got it. Yeah, thanks.
We need to import it, right, Shrikant?
Directly
Just
say
open it.
open and point to that location. It might prompt you that this is something, external project, trust it. So you say, yes, I trust this project, and then you should open that project. How many of you are able to open that project?
I'm able to open.
Okay,
I'm able to open it.
all right.
Shrikant, shall I share my screen and can you guide me?
Just give me half minute. Let me ensure that Confluent Kafka is uploaded successfully on your folder. I mean, a shared folder. The folder name is Confluent hyphen 53.3. That's the version Confluent Kafka, right? Is done. So that is also you can download that tool. That is something you'll require for your Avro serializers and deserializers. Okay. I'm sharing my folder structure with you. So if you look at the chat box, right, it's the third folder, Confluent hyphen 53. That is something you need to download. Okay, so that can be done later on also. Though it's a big folder, so let's not do that. All right, you can share your screen now.
So, able to see my screen?
Yeah.
So I downloaded the folder on my download, like the download folder, like this one, JSON, this one, right?
Open that folder. Okay. So copy this path. Copy this path. Control C. Open your IntelliJ. Close this IntelliJ. Close this IntelliJ. Open your IntelliJ. Open. Let's wait. Open. Click on a file. Main menu. Open. Okay. Control V. Control V. The path you have copied. You can paste that path. Control V is not working.
Not working.
Okay. So we have copied that on a desktop, right?
Desktop, yeah.
Okay, fine. So click on Ubuntu. Yeah, desktop.
Download.
Download.
It is in downloads or desktop?
Downloads.
Okay, download. I don't see any folder there. Okay, click on a desktop.
Shrikant, I think he downloaded it in actual video, not in lab.
Yeah, actual video actually.
Oh, it's not downloaded here, right? Download here actually. Okay, in the lab, under the lab basically, right? So there is one browser here, right? Can you see this one? Use that.
Okay, okay.
Okay. All right, fine. So quickly complete this activity. So, or do one thing, I'll give time for this downloading and all kind of things. It's very simple. So if you look at this, right? So code, and this is the project, these two projects I shared, right? This folder contains all the code we have seen so far in the class, right? And this is something
Shrikant,
we'll,
please share your screen.
yeah, sorry. Okay. So this is the folder contains all the code we have seen during the, our 3-day session. And this is something, Avro serializer for which you require a Confluent Kafka, which I already shared. And JSON serializer is fine. You don't need to download any other things, right? So this is the proper IntelliJ IDEA folder, right? So if I open let me copy this path. I'm just giving you some idea here, right? I'll copy that path here. So if you see here under the code, right, you see some small icon over here, right? Black icon, right? So that's the IDEA project. It indicates this folder is contains the complete IDEA IntelliJ project here, right? So just select this one and it should work here. Okay, open. So currently it is already open, so I'll not open it again. Yeah. So make sure, if you see something like this, there is no black icon here. It means that code is not something folder which contains the project. No, only folder which has a black icon there on top of it, right? That's the proper folders project. Okay. So that is the indication of a IntelliJ project. I hope it's clear. All right. Now understand first, and then you can start working on it. Okay. I think I might have explained yesterday, but I'll repeat that again. Maybe some of you might not be there yesterday. So in the main folder, we have resources. Okay. Let me do one thing. Okay, fine. So typically when it comes to Kafka, right, you're not going to send a message like this. For learning purpose, this is fine, right? But actually you're planning to send a proper key and then value. All right. Key can be a string, all right, but value can be a complex object. Remember, right? It can be complete, a record. It can be a JSON object, JSON document. It can be some other type of data, right? But yes, so this can be complex, right? So let's I explain you, right? So for example, if you have a store ID, right? Now, when you go to any store and when you buy something, what do you get? You get a complete invoice, right? And so so the moment you swipe your card at that POS, where that cashier is sitting, right, you get a print of invoice, but that invoice needs to be sent in a real time to multiple teams. Maybe some team who is taking care of shipping, some team who is taking care of loyalty points, some team taking care of maybe some. Just give me 2 minutes. Okay, so basically your object can be a complex thing. Complex, I mean to say, maybe you have some, invoice number, the person who is sitting there, cashier number, transaction amount, right? Maybe home delivery. The value can be a boolean, yes or no. If yes, then address, right? So this is one object, and this is a kind of a child class, I would say, right? So address is, it has its own fields here, so state number and PIN and all kind of a things here, right? So then line items, right? So maybe you have purchased 3 products as a part of this particular invoice, right? And then some other details basically. So now here is a items here. So items are itself a array of a record, right? So how many line items you have purchased? 3, right? So you will have, some POJO for line item is a kind of a child class here. The main is this. So line item has some the item number, and then the price of that and all kind of things here, right? So there are 3 products here. Okay, so this is the array, right? So likewise, so actually your data will be, your object will be something like this. How do we create, how we can serialize this and deserialize this, right? So if you have a string, key of type string, value of type string, or integer, or float, or double, right? Those things is supported by basically a Kafka serializes and deserialize. But when you have value something like this, you need to use either a JSON serializer, deserializer, or Avro serializer, deserializer, or you can use a Google's protobuf, one more serializer. Okay, so many people mostly use, this is something Avro, and many people use protobuf also. I don't have example for this. These examples I have shared with you, right? So now we are going to try a JSON, and for Avro you'll require a Confluent Kafka, which I shared. Make sure you copy that into your lab, that folder, and you set that in a path. Okay, because there are a couple of things, I'll come to that later. Okay, so now I'll explain you how to do that for a JSON. So here I'm using this particular fields here. I explained you yesterday, right? So basically this is the one record which represents one complete proper transaction, right? So this is the transaction ID, this is the transaction date, this is your customer ID who purchased this product, and the amount of transaction, the product category, that is exercise and fitness, and weightlifting gloves is basically product from that product category. Category is fitness and exercise and fitness. This is your city, and this is your state, and then mode of payment, right? I'm not reading this file. If you can go ahead, you can read the file, and you can create events for each and every record, and you can keep on pushing it to the Kafka, and then maybe you can use Streaming API to find out, right, what's going on in the runtime. Maybe it can be anything, right? So maybe I would like to see state-wise average sale in last 2 minutes, or how many orders being placed across cities. Okay, so those kind of things you can do there. Okay, so I'll leave it to you, but I'm just getting a simple one record. I'm hard coding it and I'm trying it. So yeah, and then if you want, you can go ahead and read the file. Okay, that's not a big code to write. All right, so I'm using Windows here, but I have shared the scripts here. So what you can do here, don't use those things. You open one more project there. Okay, you have that scripts, you simply copy that folder here. Okay, delete this folder and copy that folder from another project which you have, which is typically used to create a start your Zookeeper and 3 brokers, and creating a topic, and starting a consumer, and then console producer. Okay. All right, now what we are doing here. So basically when you want to create your own class, complex object, right? So this is not a complex, it's a very straightforward object. Just no any hierarchy, no relation between these classes. It's a plain class basically, right? which has a transaction ID, transaction date, customer ID, transaction amount, blah, 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 right? So what we can do here, if you look at the pom.xml, it is already provided to you in your project. So you don't need to, struggle to get this, and fixing those issues will take some time. So it's already provided. So as a part of this plugin, what is that plugin? Plugin is JSON schema to Pojo. You just provide the schema, and this plugin will convert that schema into Pojos, and then you can refer it in your producer. You can create objects of those for those Pojos here, right? So there are some version to this plugin. We are going to generate the classes here. The goal is this, right? And where is your schema defined? This is your source directory where your schema defined. So this is the source directory. So resources and schema. Make sure you have a resources folder, and resources folder has a schema in it. If I expand this, then we have one file here, right? So whatever the files you have, maybe one file or two files or three files, doesn't matter. Or it will take all the files one by one, and it will start generating Pojos for you. Where? So target output directory. Where is the output directory? Source main Java, right? So this is the source folder. But if you go to the schema file, right? I mentioned, so I want this folder to be created. Maybe you can call it dispojos or types, or basically we are creating our own types. So I mentioned your types, right? So this folder will be created, okay, whenever you compile your project. And then, so txn is the object we want to create here with those kind of properties. Properties means class fields. So this properties indicates what all fields you want, right? So I want a transaction ID, colon, so it's what is the type of that? So this is your key, this is your value. Value is itself a key value pair because type and then string, right? So here I am taking transaction amount as a number. So when you are using a JSON schema, now it's not possible for me to explain what is JSON schema and JSON document in detail, right? But JSON has its own types, okay? So maybe you can, explore on that part. What is JSON? What is, I'm 100% sure all of you are using JSON formats in your projects, okay? So it has its own data types. That's what we are using here. And yeah, right? So if you go to the Java and types folder, and if you look at this, right? So transaction amount, where is the transaction amount? Yeah, right? So transaction amount, it has converted from your JSON type of number to double, right? So there is some implicit conversion between the JSON types and then Java types. We might have the number types or might not have, right? But it will do conversion on its own, right? So along with the lot of Jackson notations here, right? And typically when we use some class called surd, all right, so basically this is something will be generated automatically for you by that particular plugin, okay? So when you refer this, this is where this class will be created. If you go to the types folder, can you see here types folder, right? If I delete this folder, I'm deleting this folder. Okay, I don't have that, right? If you come to the Maven and if you go to the life cycle and if you say compile, right? What this plugin will do, this plugin will look at this particular schema and it will create a folder types, and within that types, it will create one Pojo as TXL. Okay? So again, that folder types should be back here. Okay, what's the problem here? Okay, I'm referring this. Yeah, I'm using it, right? So basically, okay, compile. All right, so you can see your types folder is there now. Okay, So since in my code, I was referring a transaction and that folder I had deleted, right? So it was giving me errors and something, this is not found, right? But after compiling it, that folder is created and this class is also created. Okay, fine. So okay, so this will be auto generated. So main thing is basically defining your own schema here. Okay, and then I'm using some log4j for logging purpose. That is something I will leave to you. So this is the package I'm writing my code. So that package will refer this for log4j for a logging purpose. Okay. All right. So let me run this code here. First of all, I'm writing a producer here. My key is, what is the key here? What is the key here? A customer ID, C1. All right. What is the value? Entire object, T1. Right? What is T1? T1 is the instance of a class TXN. And from where you're getting, this is something you're getting from the types folder, which has generated automatically by your plugin. Okay. So topic is a TXN. I don't know whether this topic is there or not. Let me start my Zookeeper. You'll have to change all these files, right? I'm using Windows here. First of all, make sure your code is running, and then I'll ask you what needs to be done. Okay, so Zookeeper is running. It is not something you must use this plugin. There are a lot of other plugins. If you are using some other plugins, you are free to use that. So Kafka server 1 started. All right. All right. So let me list all the topics. So TXN is there. So I'll produce now here. Okay. So while producing, you are aware of this Bootstrap server, topic name, Bootstrap servers, a list of Bootstrap server, key serializer. So key is string, so I'll use Kafka's string serializer, right? Value is not something, right? So here we are defining a JSON serializer. Where is that? I have provided one folder, SERDs, serialization deserialized, right? So in that we have one JSON serializer, right? So JSON serializer is using Kafka's, one interface serializer, which will serialize your own object. Now, what we are passing here? Our own TXN object, and there's a one object mapper, right? So is basically a class which will take care of serializing your entire object of T1, right, to a byte array. Okay. You don't have to overwrite all of the kind of things. It's a simple thing, so you can go through this. Similarly, we'll need a deserializer. Okay. All right, fine. So let me close this. Okay. So let's go to the producer. So I'm creating the instance of a producer, creating the instance of a class TXN. I'm setting all those fields there. Okay. So if you go to the types and if you look at this, all these methods are there with TXN ID, right? We are setting some values. So we are creating the instance of a class T1 here. And then that's what I'm passing as a value there, right? This is the record and producer.set. I'm sending that record. It's a simple producer. Okay. And flush and then close, right? Let me do that. Right. So let me, so here is my consumer, my group GRP1 and its earliest, right? So here I'm using key serializer is what? I'm using string, right? What is the key? Customer ID. What is the value? Entire object. Now here we need to deserialize it, right? So while deserializing, so you need to add one more property, right? Because when you are using a consumer, you can read to many classes, right? Many topics, and every topic can have different classes, right? So which class you want to deserialize here, right? So value class name config, I'm saying I'm going to deserialize transaction class, transaction.class, right? There's additional things comes here, with the compared to regular consumer here, right? Remaining things as it is, right? So let's consume this. Right? So you can see here, right? Disconnected. Why broker 0 is not running? Okay. You can see here broker 2 is not, broker 0 is not running, right? Let me try again. Right? So now since your broker 1 is running fine, okay, 9092 disconnected, but now it is connected, and you can see this is what we have produced, right? Exactly, this is your key is C1 and value is basically a instance of a class TXN. Is it just the reference of that object, and this is your data basically. Okay, now what is happening here? So we are taking that key value pair as a JSON object, right? We are serializing it and we are storing in a Kafka broker as a byte array, right? And consumer is taking this byte array, right? And it is using deserializer, and that is back to your kind of a key value pair data. That's what you see here. Okay. Now, if I go and run a consumer here, right? So consumer from beginning, let me run this as well. Group ID is, I'll find. So I'm not using a serializer. I'm not using a serializer, right? So what happened here? By default, console consumer is using what type it is using for your key and value, guys? When you are using a console consumer, what is the type of key? What is the type of value by default?
String.
String and JSON.
Right? No. String, right? So
Yes.
here you see it's like a JSON, right? But this is not a JSON object. It is simply converting into a proper as a string only, right? You need a proper JSON serializer to parse this, right? And that's what you see in the consumer, right? So I'm extracting all the fields from that JSON document properly, transaction ID, and then transaction date and all those kind of things. Okay, understand. So when you are using console consumer, it is giving you as a kind of a string only, right? Right.
But can you go back to the producer again? So in producer, we have mentioned the type of the key and the type of the value, right?
Yeah, it's a JSON serializer.
And
You're
now in
serializing that object, complete POJO as a JSON there in the
correct.
these things.
Now in consumer, you are saying if we are not mentioning this JSON serializer over there, then it will be by default taking its own.
As a string, yeah. Console consumer, okay? So in a consumer, obviously we'll use a proper JSON deserializer. Right? So record dot value. Now here you have all the values, record dot value, right? So you'll get a complete object here, and then you can play with that because it is deserialized properly. Otherwise, it's like a one string. Understood?
Okay.
Okay. So now what needs to be done, right? So here is exercise time. Okay. So I want you to go to the producer and or exercise. Okay. Tick student class. Okay. And SID and S name and maybe phone number or maybe address. Just one thing, right? Just define these 3 fields there. Okay. In your schema, add one more file at student.json. Refer this. All right. And compile your code. Then add one more student producer. Okay. Or if you want, you can change this code, but take a copy of this, right? So instead of this, probably you'll be creating the instance of a student and give some dummy values there and produce it. Go to the consumer and change your code for this particular thing. Here it's going to be the student.class and yeah, obviously value will be student. Okay, and here also it will be student. Remaining things should remain same. Wherever it's a key value, so value has changed from txn to student. So make those changes and let me know once you're ready. Okay, clear everyone what needs to be done, guys?
Can you just share that what needs to be added in the student class in the chat group?
Sure. SID, SNAME, address. SID, SNAME, and address. Simple. So don't play with the existing TXN schema. Keep that as it is. Add one more file and compile your project. It should create one more Pojo under the type folder as a student. And then you start making changes into your producer and a consumer. Go ahead.
Shrikant?
Yeah.
One question. So you also mentioned like a consumer can consume from multiple topics, right?
Mm-hmm.
Yeah. So in this case, since it is bound to that schema, we are using a deserializer, right? Which is not generic, which is a particular schema we are passing.
Mm-hmm.
So how does that handle, right? If we have multiple topics and different messages coming in.
Okay. So how do you handle in Java? When you're not sure what object, what class you're going to use, what you
We'll
go,
check for the type. Yeah.
we would object, right? And then
Yeah.
we check a type, right? We'll be doing
Yeah.
something similar on that.
Okay. Again, like we have to handle it.
Yeah.
Like I was talking in terms of the deserialization configuration because right now your consumer is bounded to a particular deserializer, right?
Mm-hmm.
So how does it decide a particular deserializer for a particular topic? Like right now,
No,
consumer is
I mean, see,
directly bound.
basically topic here is what? Topic is this one, right?
Correct.
I'm
Now if there's
expecting,
one more transaction,
yeah,
right?
so there
Let's
may
say.
be a one topic or a number of topic, right? So when you are reading, when you are consuming the messages from one topic, you know what class it is, right?
Yes.
Right. So at the high level, maybe you will refer as an object and you will check its type. If it's a type is this, then you will be using this particular class, right? Else other class.
Okay.
Okay. So here I'm talking about only TXN, right? So here it can be a kind of a generic then. And then that is something we need to handle through your Java.
So even the deserializer would be a generic one, and then later we internally deserialize it for our
Yes.
or map it.
Yeah. Yeah. How much time you will require for this, guys? What do you think? 20 minutes, 25 minutes, 30 minutes, 15 minutes? Your chat box. Hello, I'm asking you guys timing. How much time you require?
20,
20?
25 minutes.
All right, fine. This folder structure you don't use, okay? This is window-based commands, okay? So copy your, maybe you can open 2 more folders, right? Just for the sake of copying it. And then later on, you can close the other folder once you're done with the copy operation. Okay, go ahead. Back in 2 minutes, okay?
Hey Shrikant, you there?
I'm back.
Shrikant, after creating the student object, what needs to be done? The shell scripting or?
After creating, after you are done with the writing schema for a student,
Yeah, that's
you
done.
added one more file there, right?
Yes.
Okay, fine. So then you compile your project. Go on the right side
Yeah, that's
and then
done.
okay. So do you see one more class in a type
Yes.
folder?
Yes.
Okay, now you go and maybe add one. You can add one more class here as a student producer, right? Copy this code and start making changes, right? So here instead of TXN, there you'll say student, right?
Yeah.
Okay,
Okay.
so those things will come here, and then you need to set all those three fields here, and just try producing it.
Okay. There's nothing to be done on the script folder or anything, right?
Script folder I told you, right? So these scripts are basically Windows based scripts, right? So you don't use this here. If you want to use this, you will have to change the scripts here. Okay, so this is typically in Windows, your home directory, your environment path is embedded in a %, right? In a Linux it is a dollar there. So those things you need to make changes. You'll have to make changes there. Otherwise you open one more project. Okay, any one project. Let's say I'm opening here another project, but I'm not opening in the same window. I'm opening in a new window, right? So I got a one more project here, right? So there are two terminals here. Okay, one is the new one project, and now here I'll go. You have your already one project, right? So maybe you use that scripts, right? For example, this is the scripts folder, right? Control C, And before you copy here, you delete this folder, because this is a window based command, right? Delete
Okay,
this
got it.
folder, and from other project you copy and paste there on the project folder level. Okay.
Yeah.
Okay. All right. Fine.
Okay, thank you.
Sure.
I have executed my producer, but it seems in the consumer, as we have mentioned, that duration of millisecond, so it is taking time.
You have changed the topic in both the places.
Yeah, let me try to produce the message again. So I'm using the existing topic only. Okay, now I can see.
You are done with the producer as well as consumer.
Yeah.
Very good. Very good.
Now suppose like if for the value deserializer, if I going to mention string deserializer,
Mhm.
then it is not going to give me that key value object, right?
You will get a value as a kind of a string, right? But if you talk about value dot, say, give me the S name or all kind of a things, right? Then there will be a problem, right? Because you're not referring to any value there. Right, so I'll explain couple of things after this. Now, for example, let me share my screen. Where is that? Okay, so right now what we have SID, S name. What is the third field? Address, right? So here it's a string, here it's a string, right? But if I say address, it itself a sub JSON document, right? So this is a room number and then value and then maybe landmark and something like this, okay? And then a state, city. So this itself a kind of a sub document, right? Then it becomes the complex, right? So how you will write a code, then what kind of data you will see here? SID, say 1, S name is something, say Tina, right? And then third field is the address, right? So it's not a one thing, it's object itself, right? So here you will see one more, just an object. And then room number, colon, value, landmark, value, state, value, and city value. This is the end of address and this is the end of your main document, right? So this is how you can increase the complexity of your object. You will not see something very simple, straightforward objects in your project. So I'll be sharing some very complex project after this activity, and then you can refer that schema for this kind of a thing. And then you try updating this, okay? So if you want, I can share this file as well, a customer file. Okay, so this is, you can take this as a SID, this you can take as a S name, first name, last name, age of that person, and then profession, designation of that person, right? And then you can read this file and you can create a lot of events and you can push it to Kafka. At the other end, consumer should be able to read this, right? Fine. Let me know if you want this file so I can share this file with you in that particular folder.
Yeah, Srikanth, please share them.
You want me to share that file?
Yeah.
Hello, Srikanth.
If you are done, you please give me thumbs up. Okay, so I'll come to know how many of you are done. And once we have good number, then I'll continue. But I want you, everyone to try this, to some extent, if not fully.
Srikanth.
Yeah, go ahead.
I'm able to consume record, but the record which I consume, like not in very readable format. Maybe because we have used logger.
Can you share your screen? I'm not able to hear you clearly.
Yeah,
You're breaking in between.
So I'm able to consume the records, but those are not in very readable format.
Okay, show me.
Yeah. Able to see my screen better.
Yeah. It is very much in readable format, right? So basically, if you look at this, right? So this is your folder in which we are creating the Pojo. The name of the object is student, right?
Yeah.
And this is the reference of that object, right?
Mhm.
After this is like output of a true string, right? So
Yeah.
SID is there, S name is there, address is there. What is the problem?
Yeah, we can we skip this part and
Yeah, your main data is this.
yeah, I got it.
Right? Yeah. Actually, we are not printing. Actually, we are going to work with this kind of a thing, right?
Yeah, only the data. Yeah,
Yeah,
correct.
but just for the sake of something we are printing here, the object. So
oh yeah,
this object is coming from this particular package. This is the object reference, and this object contains these three fields and their values.
Yeah, got it.
Okay. All right.
In this JSON, the serializer, which we have put in the SOD folder, I can see we have with address and set address.
Yeah. So in producer, you need to set, right? And in consumer, you need to get, right?
No. So I can see like we have with address methods as well. With address and set address.
Hmm.
So what actually this with address? Like I mean with and set. So any specific difference between these two?
We are using with, right? In our code.
Yeah, I can see we are using with, but I'm not sure why, like we can use the set also, right? So what is that with?
Can you try at least one, the last field with the set also instead of with? Just try this.
Okay.
It's working with set as well. I tried
Work.
also.
So if you are using some builder pattern, right? So typically there we use with, right? And if you are like setting some values of a class, typically Java means, right? There typically we refer a dot set. Can I have a number of, how many of you done, guys?
And done.
Dharani is done. One, only one. Tina, you are also done, right?
Yeah.
Okay.
Shrikant, when I run this code for the, I'm done with the producer while
Mhm.
consuming. So what should I mention in the group ID?
Group ID, you can keep this as it is. Okay. Have you changed group ID, Dharani and then Tina? No, right?
No, we haven't changed it.
Hmm. We can use the same topic. We can use the same, you know.
But how we
See,
can?
this will work. This will work if it's a JSON thing, right? But if you are using some different thing, then things will be because there is a problem, right? We just cannot stick to one particular thing. So JSON schema is different. So, you know, as a consumer, if I look at schema JSON document, I can figure out what is the JSON schema. Okay. But if you do not have a fixed schema and then randomly you're getting a field with the 2 fields and 3 fields, then there is a problem. You need to stick to some fixed schema there. But JSON schema that way is a bit flexible. You don't need upfront some kind of a schema at your consumer level to understand what all fields, because JSON document is, you know, when you use a JSON parser, right, it can figure out what fields are there. You can share your screen, no? If you want me to share, you see Ravi.
Yeah, just a minute. I'm just checking.
So Rilesh is also done. 3 people are done with this, and probably Ravi is also done. What about other Rutuja, Poonam, Ashish, Siddhesh, Mr. Vaibhav, and then Arvind, guys?
Yeah, hi Shrikant. I'm done. I was just about to type it.
Okay. Rutuja is done. And Ankur, हुआ कि नहीं? Okay, Ankur is done.
हो गया.
Yeah. All right. Arvind bhai, are you done? Shubham, Abuli. Abuli. Are you there?
See, can you see the screen?
Yeah, I can.
So I created. How come we come to know that this? Whenever we create a topic, how we come to know that this topic belongs to this group?
Who would like to answer this question? Tina?
Sorry, come
Dharani?
again.
Yeah, repeat that question.
So whenever we create a topic, like I used the create topic command. So how come we come to know that this topic belongs to that particular group, consumer group?
You can check the describe command, right?
Yeah, but I have almost 3 to 4 groups. So do I need to list it again every time? I did the same here.
Understood?
So here we can see, right, that this test 3 belongs to this group 1.
Yes. So first I listed the group, all the groups, 3 groups. So I wanted to understand which topic belongs to which group. So I was searching for the student, actually, which belongs to that group. So I listed each and every group.
See, each and every group you can have a consumer group for reading any type of topic, right? So if you want to see what my group 1 is consuming from where, then you can use this command, you can see. So any group at any point in time, it pointing to what? One group, right? One topic. Or maybe more topic. If your consumer is connecting to both the topics. Come again, what is your question?
Yeah, so I wanted to understand. So I created one student topic, right? Through SHS command, SH file. So I wanted to understand the student topic belongs to which group.
It's not like this, right? It's not. First, you create a topic.
Okay.
Right. And when you start consuming these messages from that topic, then your group ID comes in picture, right?
Yes.
Right. So your now for example, in this case, your group ID you mention is a my group, my GRP1, right?
Oh, while producing, you mean to say?
While consuming, group will come into picture with consumer side only.
Okay.
Right. So producer is producing to that event student, and consumer is consuming the event from that topic student.
Mhm.
So, I mean, can you repeat your question? How?
Yeah. So just for, I will show you the example where I was stuck.
I'm forgetting your statement,
Yeah,
you know,
yeah,
but
yeah.
directly there is no relation as such. Yeah, go ahead.
Yeah. So while consuming, I changed the I changed the topic name and everything. So I wanted to understand what should I enter in this group ID field. See, I changed the topic name. So I wanted to understand what field should I enter in
Okay,
this,
okay.
my group ID.
Now you can keep this my GRP1 as it is. Now you must be wondering, like, I changed my topic, so should I change my group number or something like this, right?
Yes.
Yeah, no, not required, right? So let me share my screen. You'll understand quickly.
So Shrikant, if he puts instead of my group, if he puts group 1 and tries to consume, still he'll be able to consume, right?
Yeah, right. See, basically when I say GRP1, you are running one consumer, right? You are running one consumer, and there you mentioned topic as say T1. All right. So this is your topic T1. Multiple partitions are there, right? So this group ID is connecting to this particular topic T1. There are 3 partitions of T1. All right. Now I'm running one more application, one more consumer here, right? So here my topic I'm going to read from is T2, right? So this is another topic here, multiple partitions of T2, but this is T2, right? So I can have a one application where my consumer a group ID can be GRP1 only. That's perfectly fine, right? But this and this has to be different, right? T1 GRP1, T2 GRP1, that is fine. But here, if you are running here, so T1 and GRP1, what will happen here? Who will explain me? If I did go with the same configuration, T1 and GRP1, what will happen here? Right? So even if this, what you are planning to run as a separate thing, right? It is not a separate thing, right? It's a part of this consumer group only, because you're pointing to the same topic T1. Confused or clear?
Not clear.
Okay. Okay. See, basically, your question is, can you repeat your question?
Yeah, so I was saying, when I create a topic, first of all, whenever I create a topic, how does it belongs to a particular group? How does it get assigned to a particular group?
When you create a topic, it does not belong to any group, first thing.
Okay.
Okay. So when you say TXN, you are using GRP1, right? So this is the topic you created. And when you consume the messages from that topic, then as a consumer, you can run one consumer, second consumer, 3 consumer as a consumer group. So we have a GRP1 for which topic? TXN, right? Now you have changed this to student, correct? So you have created the topic student. Consumer, you are not started. So there is no question of a consumer group, right? But then you are planning to run 3 consumers to read the data from topic student. Why? Because there are 3 partitions, right? So this is C1, C2, C3, and then group ID. If you want, you can keep the group ID same, GRP1, right? Why? Because topic is different now here. Here topic is this one.
So you can name anything for that.
Yeah. As far as you are referring to a different topic, you can keep your group ID as it is, same, or you can change it if you want, right? So typically, maybe it's a good idea to append your group ID with your topic name, like stu and then GRP1, right? TXN and then GRP1. So whoever is looking at your code can figure out, oh, you're reading that from the topic transaction. You're reading the data from the topic student. But there's no, you cannot say I created one topic, how to know which groups is belong to. No, it's not like this. So after creating the topic, you push messages to the partitions, right? When you start consuming the messages from those partitions, then consumers and all these consumers belong to one group. It can be anything. GRP1, GRP2, GRP3. Make sure it is not repeating for the same topic. That's it. I think it's clear now, right?
Yes. So just for 5 minutes, I'm sharing my screen. I'm
Sure.
stuck.
Sure, go ahead.
Topic name as student. Okay.
Did you create that topic?
Yes, I created a topic using this create topic.
Okay.
This is the topic. Okay.
Okay.
Now, go to the code. So I produce this message on the topic with student Ravi 10 roll number and something. Okay. Now I'm running the consumer. Suppose if I put the group 1, I'm changing the group to anything.
That's fine.
Student. I'm changing it to student. Is this correct?
Yeah, that's fine.
Yeah. Okay. I'm running this. I will just produce one message now.
Yeah.
First.
Are you running consumer?
Yes, I will just run the consumer first. Then.
Yeah. All right.
Yeah, I got the value now.
Yeah. See, basically you have changed your consumer group. That's why you're able to see this message, right? But
Okay.
earlier group has already consumed that message. You're not produced one more message. It's the same message you produce, right? So you're now the consumer you're running as if it's a different application, right? So that why different application? Because consumer group has changed. Dekho, you know, your consumer group is Ravi, right? Your consumer group name is Ravi. Ravi has already consumed this message. If you run your consumer named Ravi again, so Kafka knows that you already read this message. So when you run a consumer again as Ravi consumer group, you won't get any message. But since you have changed your group name to something else now, that is a different application altogether. And there you are thinking, I would like to start reading the message from beginning. And that's why you are able to see the message here.
Okay. So if I change the group name again, I will get the message again.
Again, yes.
So Shrikant, so we like don't come to know about which exact consumer has consumed the message in that group, right? We are just mentioning the consumer group name.
No, we can figure out, na? So we can figure out, not exactly, we can figure out what consumer is consuming, right? What is the key ID, what is the offset number, what is the value, all those kind of things you'll come to know, na? Does that answer your question or?
No, I'm slightly like confused. How would we come to know that?
Come again, repeat your question.
So whenever we start the consumer, right? If we start the consumer 3 times, right? If we run the consumer sh file 3 times with the same group name. Okay. So this means that we have started 3 consumers in that same group, right? So how would we come to know whether which consumer has consumed the message from that particular group?
Okay. So all the consumers are part of same group, right?
Right.
Okay. So let me, Ravi, did you get that message again?
Yes, I got the message again.
Let me share my screen. So Anant, help me to, you know, so you are saying, see, this is your consumer group, GRP1. And as a part of one group, you are running 3 consumers, all right? C1, C2, C3. All right, then what is the question?
Right. So let's say we have produced some like message. Okay. So when I run the group first time, okay, first time I'm running the .sh file. At that time, Okay, might be my question be wrong. Like once we are running the sh file for group, we can see that that message which is consumed. Okay, so that means that first consumer has consumed that message.
Yeah, as a part of your consumer application, you are starting only one instance of a consumer. So it means what? You're running only one consumer.
One consumer. Okay.
And in case by chance, if you have produced these messages, obviously everything will be consumed by this consumer, right?
Okay.
Right. Now you are starting another instance. You have started another instance. And now you are producing, a couple of messages. Now what will happen here? Now Kafka has to decide based on the hash code whether they should go to the C1, C2, C3 or like this, right? So that bifurcation will happen there. Got it?
Okay, so that bifurcation will be done by Kafka itself.
Yes.
According to the hash code.
Right.
Okay. Okay, got it. Yeah. Then on the console like itself, we would be able to see like if we print the offset and offset
Exactly, right?
number.
So right? So basically, when this consumer is running, there are 3 consumers are running, right? And we saw that, right? So if you look at the output window here, you will get C1, C1, C1. If you look at the output window of this, right? C2, 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 from which partition it is cutting, what is the offset of that number, everything we'll be able to see there.
Okay, right. But do we have a control on the specific consumer? Like, let's say consumer 2, I want that consumer 2 should read this particular offset, let's say offset number 2.
No. You cannot say offset, right? If you want to run one standalone consumer and would like to consume the message from specific partition, right? We call it standalone consumer. That is possible, right? So we don't know, we don't know what all offsets we have there, right? So maybe today we are starting from this, right? But after 7 days, right, probably all offsets will be deleted, right? So it's very difficult for us to keep a track what all offsets are there in a one partition.
Okay.
All right, so guys, let's quick. How many guys are left? How many of you are still yet to complete the this code? Can I have a quick? Sorry.
Yeah, Pratik here. I have a doubt.
Yeah, go ahead.
Yeah, so like required
Pratik, you are not clear. This is very. Can you be a bit louder?
Am I audible now?
Yeah, better. Go ahead.
Yeah, so when I'm producing, and after that when I'm starting the consumer, I'm not getting any messages there.
Okay, share your screen.
Yeah.
Guys, those who are done, help him, help Pratik to fix that issue. Those who are done, help Pratik to fix that issue.
Yeah, so if you can't initially write while creating a JSON schema, I selected number as SID, student ID.
Okay.
So yeah, so when my page was created, it came as double. That's why in the producer also, I use double serializer.
Okay.
When I run this student producer, I can see this message process. Yeah, process finished with exit code 0.
All right.
And my topic is student topic.
All right.
And in the student consumer, I use the same topics. Student topic. And I created a group, student group.
Okay. Okay.
So when I'm consuming, don't see
what is the topic name in consumer?
Student topic.
Student topic. Okay. Show me your producer. Student topic. Okay. Yeah. So others guys.
Can you show the consumer? Go little down. Okay, so you have used logger, right? Logger.info. Can we check logger file in resources? I think we have logger file in resources. Yeah, log4j. here everywhere we have error, right? So we need to change it to info, right? In line number 17 as well as line number 24. Can you change it to info and try again?
Okay, sure. I think I missed that part of.
Or do one thing, instead of logger.info, maybe you can use sys out there.
I don't think that matters.
See,
I
basically
also have
here,
the
no,
same thing.
don't change it. Don't change this. Okay. See, basically, Kafka is also using log4j under the hood. Kafka will display a lot of things what Kafka is doing, right? So root level is basically a Kafka, right? Application level is what yours level. There you can say info. Okay. So
Pratik, can you show the Pojo for a second? Scroll down. And student.json. Yeah, this looks good actually.
So I'll try running the consumer again. Let's see.
Yeah, now you can see some messages, right, related to Kafka. I think there is some issue related to that in logger.
do one thing, and then use your, instead of logger info, now just use a sys out there.
Yeah.
Your code is running fine. Your code is not failing anywhere, so that's fine. But why it is not running? Why it is not running, working for others? It's working. Have you changed anything in your logger4j dot?
Yeah, I have changed.
Okay.
Actually, I'm facing the same type of issue. I am not able to see anything, any login consumer. So I have changed there and it's working fine. Otherwise, we need to change it to logger.info into system out println.
Okay.
Pratik, you change the deserializer also to consumer, sorry, double deserializer, right? Okay.
You'll have to produce here because this group has already consumed all the messages.
Yeah, you will not be able to see.
Why a consumer is also add a consumer dot close there, okay, in finally block. While true, I think you can check the code, use the same code as your consumer and make a copy of this and refer it, So I think while consumer, you're polling, and then for this, still not working, right?
Can you run producer now again without stopping the consumer? Yeah. And go to the consumer tab. Yeah, we can see the values.
Yeah.
Yeah.
All right.
Yeah.
Good.
So if you don't want to use system out println, then you can change info in logger log4j2.xml. It will work.
Logger.info is also working. Second last one.
Yeah, I'm not sure how come it started working now.
No, we are using sys out now.
Yeah.
right? So that's why you're able to see key, right?
We
Okay.
can
Go to
see
your
it in logger.info as well. Second last and last
So
one.
later on, you can change your that 4J property. Okay, should work. Hmm?
Okay.
All right, guys. So let's take a break here of 15 minutes and then we'll continue.
Thanks.
Sure. All right. Let's start. Okay. So this is how we use JSON serializer and then JSON deserializer. Okay. Now let's understand what are the problem with the JSON serializers. Okay. Now, if you look at this, I'll show you a couple of files here. I have one CSV file. Can you see my screen? Guys, are you with me?
Yes.
What is the
Yes.
size of this file?
Yes, we can see.
What is the size of this file?
40 MB.
40 MB, right? If I open this file, control end. So there are around 4,70,000 records. Some flight details are there basically. Okay. I'll close this file. This is a plain CSV file, comma separated file. Okay. I'll open, it's the same data, but what is the size of this file? JSON file? 83 MB, right? So this CSV file contains 4,70,000 records. And if I open JSON file, okay, which has only 3 lakhs record. So 1,70,000 records are not there. Still, the size of this file is double. Okay. Is this clear?
Yeah.
If I take all 4,70,000 records in JSON, probably the size will be more than maybe 95 MB. The size of the CSV file is only 40 MB, and the size of JSON file is almost double of that. Okay, now understand when, why not to go for a JSON serializer. Now, when it's a CSV file, we directly have some data in it, SID, SNAME, and then address, right? And that's what you are sending to the Kafka, right? So you are sending only this required information, right? But when you are sending a JSON docs to Kafka, right? What happens here? Your data is not like this. Your data is column name, column value, column name, value, column name, value, right? So every record has got that schema. For every record, your column name is repeating. Value definitely will keep on changing across all the records, right? But this information, column header, is going as a part of each and every record, right? So, if you look at CSV file, or maybe, you are not using JSON, right? Just some text here. Then these are just the 3 fields and not 6 fields. Okay. Now, if you are sending this to Kafka, this is your partition 0, right? So entire thing is serialized and stored there, right? And for every record, you are repeating this. You are repeating a column names there. So for every record, this is maybe offset 0. This is your offset 1. But same information is repeated in each and every event, right? This is offset 2, right? Same information you are repeating. So when you are sending a big events and the number of events, right? So somewhere, because of JSON things, you'll have a performance issue, right? And whoever consume those events, whoever consumer, right? You are using JSON's deserializer there. So it's very easy for consumer to deserialize it, because deserializer is inbuilt using your JSON parser. It understands, oh, this is column, this is the field, what is the type of that. Everything JSON serializer will figure out for you easily. So that's the good point here. Okay. Now, guys, are you with me? Are you getting this issue?
Yes.
Okay.
Yeah.
So when it comes to a big event or big message and yeah, go ahead.
Shrikant, I'm so sorry. Can you please repeat this again? I actually missed this point.
Okay, so you understood difference between CSV and then JSON at least?
Yeah.
Okay, fine. So now when it comes to when we are using JSON serializer, what happens here? We are sending this message, right? Which has got complete column names for each and every record.
Yep.
Right, and basically just imagine here the actually your actual data is this only, right? But every record will have some kind of a column header, and that is too much for Kafka to store and retrieve process, right? So it will somewhere it will hit on your performance, because just imagine I told you if it's a CSV data, it's a 39 MB, right? But if it's a JSON file, because JSON file has schema repeating for all the records one by one, right? So that is something 90 MB, huge difference. So obviously you are storing this kind of a data on a Kafka broker there. You are taking more storage. Obviously it will take more time to write. It will take more time to fetch from the consumer and write from a producer. So there'll be some impact on a performance. Okay, if your message is small and the number of events, is not that huge, right? So then probably you can think of using the JSON serializer. So typically people use Avro serializer. Okay, how Avro serializer? This is supported from Confluent Kafka. Okay, now instead of sending this entire message to broker, how Avro serializer works? This is my producer. Here I am using Avro serializer. The way I define your schema, right? The way I have used a JSON to schema plugin, which I converted your schema into POJOs. Similar things is happening here also here. Okay, but here it's not generating a JSON document. It is things converted into a proper binary data. When you open a JSON file, you can see the proper text data here, right? But if I open an Avro file, it is in a binary format. You won't be able to see any text there. Okay, it stores your data in a by default in a binary format. Now, when you are using a producer and using Avro serializer will take only data. Okay, as a event, let's call it a message one. That's what will be sent to the broker, right? So broker contains only those 3 fields or one event as a part of one, right? And consumer, when you consume, right, here also you will get the same event, right? The problem is, where is the schema? In JSON document, you have a built-in schema, right? So consumer can easily figure out what are the fields and what are the types of fields, right? That is not a thing, that is not happening here in case of Avro, right? Then Confluent Kafka brings in one more service called schema registry. Schema registry. Right? The way you are starting your Zookeeper, Kafka broker, right? You need to start this service as well, right? This is the additional thing here. What is that? Schema registry. Now, when you are producing here, right? So every message, every message is tagged with a version, right? Let me show you here. Open Avro serializer. Okay, this window, right? So if you look at this, okay, so process is same here with a small changes here and there, but we are starting a schema registry and we are starting this is a one service we are running additionally in case of Avro serializer, okay, and that is running on a port 8081. So if you go to the Confluent scripts, right? So here is the one additional scripts which you need to run, and that's the part of your Confluent Kafka. You won't see this kind of a thing in your Apache Kafka. right? So where this schema registry is coming into picture, guys, focus here, right? Where now, if you look at my particular schema, right, syntax is a bit different in case of Avro serializer, guys, understand, right? So there it was the properties, there was no version. This is the name of your class, right? What type of event it is a record type, and that will go in a call folder Avro, right? So the name of field is EID, the type is integer, the name of the, right? So it has its own types now here. We are not using JSON serializer, so we'll not go with a number or something like this. Okay, so all right, so basically field is a array of 3 fields here. These are the 3 fields. So some slight difference between your the way you define your schema. Okay, right? So this is your version 1. Tomorrow, maybe one producer is using version 1 and some other application on other system, right? Maybe they have modified this version. They have added a phone number also. Okay, so if you understand now, this is your producer 1. I'll say old producer. This is producer as new, right? Here we have a consumer new, right? And we have a consumer old, right? If you are producing with the 3 fields, you should be able to consume that. Obviously here, this consumer is referring the version V1, which has got a 3 fields, right? So this guy is also using the version 1. So here is no problem here, right? But if this message is consumed by the new consumer, where the new consumer is referring to version V2, which has got a 4 fields here, right? But since you are passing 3 fields, you will not have any issues here. So anyway, when I say consuming, even if you are using V2 here, but you got only 3 fields here. So anyway, there is no question of a 4th field. It will come as a kind of null there, right? But when you are producing a V2 here, right? So here also V2, here also V2, here there is no problem here, right? But if the old consumer consuming the new record, where we have a 4 fields here, right? As a part of V2, we have a 4 field. As a part of V1, we have only 3 fields, right? So obviously this field will not come into picture here, and you will be able to see you will be able to get the 3 fields here, right? So all these kind of things can be handled very efficiently if you are using Avro serializers. So every message you are producing to Kafka brokers is stamped with some version number. And that's what you see here, right? Version number 1. So I have an example of all this what I'm explaining here. I'll share that code. So you can try running an old producer to, both the consumers. New producer consuming, both the consumer should consume that data. All right, now, so in case of Avro serializer, so when you are producing, right, this is my producer Avro, which is using Avro serializer, right? So it will produce a message. What are things are there in message? 3 fields, let's say SID, SNAME, and address, right? So we are not passing column name like a JSON. No, only fields here. The fields and field names are not going there, and that's what going to your broker, right? But with one additional thing. What is that? Schema ID, right? And what is that? V1. All right. And when you consume as a consumer, when you consume that, right, you get the same message with the 3 fields, and along with you get additional information. This message is coming as V1. Okay. Now, where is this V1? From where this consumer will get this version schema? For that, when you are producing messages to the broker, only message will go to that broker. And what is the version you are using in this message? V1, right? So that version details, that schema details, right, is uploaded into a schema registry, which is running here, schema registry. right? So you are passing this information. So basically it's like this V1 and the complete data here, right? So this part is going to your Kafka broker, right? And this part is going to your schema registry. And that message is tagged with that V1, right? So when the same message broker is taking, right? So broker understand, oh, this message is stamped with the V1. Let me get that V1 details, how many fields are there and what the type, right? The consumer has got a message also, and the schema it is referring here, right? So consumer has got both the things here, and things will be way better than your JSON serializer. Guys, understood?
One question. So when we refer as a message, right? So a message would be a key value pair, correct? So
Correct.
in one message, it will consider both the key value pairs in one message itself, right? Or it would be only fields as in it will be
No, no,
only
no, no.
values.
When I say 3 fields, right? I mean to say maybe this is as a key and this is as a value. But yes, when it comes to event, it's always a key value pair, right? For example,
Okay.
if I refer this, right? So what is this? This is a class, right? EID, ename, email, right? If I go to the producer, right? Again, I'm setting my EMP to EID, ename, and then address. 3 fields, right? What is my key here? My key is okay. So okay. So what I'm doing here, what I'm passing here. What I'm passing here. So this is producer record topic and then EMP. I'm not passing any key there, right? If you want, you can say EMP dot and then maybe ename, right? So this is something going as a key there, ename. And then value is going as a complete AMP object. Got it? So not set here, we'll have to get, right? Get ename. So this, if you want, you can send this key and EMP as a complete object. But I told you, right? So these two properties are compulsory. Even if you're not passing a key there, you have to specify this. Okay. So I'm passing only a object there as a value there. Right? It's the same code, right? So only difference is basically, you know, your Avro serializer. We are using a different serializer here. Okay. And when you say Avro Kafka Avro serializer, right, which is a part of your Confluent Kafka, right? You don't see a SerDes serialization and deserialization, right? If you look at the consumer, here also we have a Kafka deserializer is a one class, right, being used, and that class will take care of serializing your this particular schema, this particular class, what you're using there automatically. You don't have to write any code. Okay, so I shared this code, you know, understand first, and again try changing, adding one more schema, and then practice this, right? So, but for this, let me run this code now. For this, I'll start my Zookeeper. I think I'm already running somewhere. I don't know. Let me check this. JPS. All right, so everything is stopped. So the way we have this bin folder in Apache Kafka, right? Similarly, we have this folder I'll share with you. If you go to the bin, right? So all those similar commands are there. Only one additional thing we require here is a schema registry. Okay. So somewhere you'll see schema registry start and schema registry stop. These are the two additional kind of things, right? For rest of the services, you can use Apache Kafka shell scripts, right? So there's no major difference here. Yeah, but in Apache Kafka, a lot of things are there, guys. Okay, so if you go to the share, right, up, you know, if you look at the Confluent Kafka, you know, so there is a right, a lot of tools are available there. Schema registry is there. you know, your lot of connectors are available. Maybe I know day one I gave you some idea, right? So Elasticsearch, JDBC connector, some by default some connectors. It's not full-fledged all type of connectors, but most these connectors are there with the Confluent Kafka, which is not the case with the Apache Kafka. Okay, so you can see here. All right, fine. So I'll share. I'll start
So
my
just one thing, Shrikant.
yeah.
So the consumer here gets the message with the version tagged, right?
Mm-hmm.
Yeah. So since we are changing the versions here, there are multiple schemas in the registry, correct? Right now. So
Mm-hmm.
how do we control, like, in terms of there's different types, right? Compatibility types and all that in this schema registry.
Yeah, so I told you, right? So, you know, if you look at this, maybe I have one producer, right? I'm producing version V1. Maybe I'm running another producer which is using version 2, right?
Okay.
Maybe you have one more producer which has changed the schema to V3. Maybe you have your 3 fields here, you have 4 fields here, you have 5 fields,
Okay.
right? So you will produce your event only to broker.
Correct.
Kafka, right?
Hmm.
Only message, right? But every message is tagged with the version. So this is your message 1 with the which version? V1, right?
Okay. Okay.
So this guy is producing a message M2, right? But what is the version it is using?
V2.
V2, right? This guy also producing. So there are different producers altogether. This guy
But
is
then the
producing one.
topic is the same, right? In all cases.
Yeah, topic is same.
Yeah.
Topic is same, right?
Yeah.
So, but when they are producing this M1 with V1, M2 with V2, right? So for the very reason, right, they also need to upload, here is a schema registry. So when you are uploading M1, only M1 is going into your broker, that message. V1 details is going with the to the schema registry.
Yeah, this part I understood. My thing is, let's say I have a consumer now, okay? And again, consumer doesn't have any control on what version it is receiving since it is subscribing to the topic.
It has, right? So actually, what is going into broker? M1 with the V1 details. So this M1 is with the version V1. So the same details will, consumer will get these details here. Okay. And then only version number, consumer will get the complete message, and this message has arrived with which version? V1, right? Now, what is V1? That is something we have not uploaded here. We are not uploaded to Kafka brokers, only V1 for any particular topic, right? So where is the details of V1? So this V1 I told you, right? So details of that V1 is going to schema registry. So this guy consumer will take out the message part, will take out V1. It will take the details of V1 from schema registry, which has got a 3 fields, right? That's complete schema details, right? So message is also there, plus schema is also there. Now you can deserialize it.
Okay, but then let's say I have like my consumer that which is consuming that now has a schema, like you'll have that deserializer also right there at its end.
At
So
consumer end, yes.
Yeah, so in V1 we had 3 fields. In V3 we have 5, right? When the message with 5 fields comes in, it will break, right?
No. See, here is a consumer, right?
Yeah.
This consumer don't have any information about what messages are coming, right? And what schema is there, right? So if this consumer is reading the data from this particular broker, right? For example, so M3 is there, but what is the schema? V3, right?
Correct.
What is V3? We don't know, right? So this guy will go to the schema registry, because when you are uploading this message M3 V3, obviously this guy has to upload the V3. What is V3 to schema registry, right?
Yeah,
so when
but then,
consumer, go ahead.
but when it is deserializing, right, for the consumer, we give the property, right, that a particular deserializer is attached. And it has a structure, right, a deserializer, like these other properties and stuff like that.
Yeah, that's what I'm saying, right? So every consumer, right? For example, let's say this consumer is running with the V2, right?
No, the reason I'm asking you this is because based on what I have checked out generally, there are certain compatibility modes. So I just wanted to understand them if possible. Like when you're changing the versions also, right?
Mm-hmm.
There are certain compatibility mode and confident, like backward, forward, and so on.
Correct.
Right.
By default, it's a backward.
Yeah.
Right.
Okay.
So doesn't matter. See, every consumer, the way you are producing with the default V3, this producer default running with the V2, right? So
Yeah.
every producer is producing events with certain fixed version, right? Similarly, this consumer may be using actually V2 here. You don't have a V3 here.
Okay.
Right. But all this schema, when you talk about V2, you are expecting only 4 fields, right?
Yeah.
And let's say this is running with the V2 and you're getting a V3 here, right?
Yeah.
So obviously V2 has only 4 fields. V3 has a 5 fields, right?
Correct.
So obviously this consumer won't be able to see the last field. You don't have that field as a part of V2 here. So in that way, it will, it has to be. So for this very reason, right? So when you are sending this kind of events to the producer, right? When you know that it is not going to consume that, right? So we need to ensure when you add new fields into your schema, make sure default value is null.
Okay.
Right? So your things will not break that. So for that, I have one code here, right?
Okay, I have a sample.
Let me show you. See here, for example, if you talk about right, let's take example of a product V1. Okay, so here as a part of schema customer, right? I mean, what I'm using here, customer, right? So if you look at this is a V1, right? 1, 2, 3, 4, 5, 6 version 1. Right? If you go to the V2 and if you show, I'll show you this schema, right? Customer V2, right? So added a phone number there. By default, value is null. If you don't put a null there, right, then your old consumer won't be able to handle this.
Okay.
Right. So I'll share this both the project with you, this both, right? A lot
Yeah,
of
that
code is
will
there.
Yeah.
So you can go through this, but I just wanted to give you, a kind of a heads of how can you use the Avro.
So again, we still have to follow those rules, right? When we are updating the versions.
Yes.
That's what,
Yes.
Okay. Understood. You just share this, I'll explore. Thank you.
Yeah. Let me make a note of this. Version V and V2. Okay. Anything else, guys? Okay, so let me start this.
Again, maybe not related right now, but since yesterday also I mentioned it, when we are consuming, if we lose a message, like in consumption, if there's an issue, if we want to replay the same offset, that is something we still, like maybe today or tomorrow, whenever you have the time.
Okay, so for this, I shared a CLI kind of a things. Okay, quickly I'll cover this and not keep it pending.
Okay.
Okay, so you can refer this file for this. Okay, if you want to run from a specific, right? So one is if you're currently your offset is you know your current offset, right? So let's say your current offset is 112, and if you want to go back by 50, right? And something like this, you can use a reset offset shift by how many offsets.
Okay.
Okay.
No, just one thing. So let's
Yeah.
say a 112 came into my consumer
Mhm.
and then that processing something failed.
Okay.
Okay, so there would be some acknowledgement, right? Like in the group on the metadata that 112 is consumed. Okay,
Hmm.
so that acknowledgement can be delay. Basically, after we are processing it, can we give the acknowledgement? You got my point, right? So that it doesn't proceed further.
No, you are saying your consumer is running and currently consumer has
So I got the
consumed
message.
112.
Yeah, I got the message,
Hmm.
but there's some processing at my end with that message. Okay,
Okay.
and that fails. So basically, I'm not able to preserve it in my side, right? Persist it, let's say. So I need to just make sure that this offset is not updated that consume. Is that possible, or we have to
Yeah,
go
it
and
is possible. Somewhere out of the box, you need to keep a track of. Let's see, from a Kafka perspective, you have received 112, right?
right? Yeah.
You have received properly, and while processing at your end in your
Yeah.
consumer, something is going wrong, and you are not able to process that record properly. It's not a Kafka's problem.
Agreed. Yeah.
Right. So when you are doing processing and if you do not get a success flag somewhere, you make a track of all those offsets.
Okay.
And then, you can go back and you can, try to pull those offsets by.
That's what I'm saying. Can we get a particular offset instead of, because what you're doing, it will replay from that point, right? All the messages.
Exactly. Right.
So
So
this is the only option, right? We have to replay from that point.
yes.
Okay.
Either from start or certain range of
So
offsets.
there's no way to get a particular offset.
I don't think so. Maybe
Okay.
I'll check on that.
Okay.
Yeah.
Okay. Fine. I'll also check, man.
Yeah.
Meanwhile, yeah. Thanks.
Okay, fine. So quickly. Okay, let me start Zookeeper. So I'm using Confluent Kafka scripts here, okay? And you cannot have both the folders with the same, commands in a path, right? So here environment variables won't help you. Maybe you can keep either Apache Kafka in a path or Confluent Kafka. So I kept up Confluent Kafka outside. So directly I'm removing the complete path now. Okay, I guess I started 0, 1, 2, and let me see here what all things are running. So you can see Zookeeper is running 1, 2, and 3. Okay. So next thing, what you need to start? You need to start a schema registry to upload. When you start producing this, right? And what is required here? Schema registry needs to be up and running there. So I'll start a schema registry also. Okay. And now I'll produce this event. Right? Server started listening for a request here. So let's produce. Right? So you can see here this particular event has been produced, right? I'll not run a consumer here. I'll run a console consumer, okay? For the same topic, AMP Avro. Right? Now you don't see the data properly here, right? And that was not the case with the JSON schema. So, JSON schema is basically a kind of by default, when you run a console consumer, right, it is converting or it is using the string type and somehow you are able to see the thing, right? So here Avro is something, though you see some text, right? Actually, I have produced this. Where is my producer? Let me produce one more time. Right? Couple of things are consumed here, right? But you see only a couple of things here. Okay. So it's not able to convert it properly, right? But when we are using Avro serializers, right, from the schema registry, it will download that version you are using here. Okay. So here you are using a class EMP, right? And that is something with the version 1. Okay. So here I will run a deserializer, right? So my group ID is customer with the V1 here. So this consumer is running with only V1. Understand? Right? But still, even if you consume the data from a new producer, right? So it will be able to consume, though maybe you will not see the additional fields here, but it will show you all the fields which is present as a part of a schema 1. Right? So since I produced 2 times, right, you are able to see your data properly here. All the fields are able to, right? So you have this code. I shared the Confluent folder also, practice that. All right. Any text messages there? Yeah, I think it's clear, Ashutosh, right? What happens in case field name is changed, right? So that's the change in your schema, right? Okay, so give a different version number, I would say. Okay, and when we are changing the schema, right? So we need to ensure generally we should keep the full names as similar. Okay, fine. Let me close this now. Okay, now what is time? 12:42. All right, now I'll show you something. Guys, are you with me?
Yes.
Okay.
So can you also share the schema registry command, because for us we need to add it
No,
in
it is
the
there.
sh
No,
file.
it is there. It is there. Schema registry command. Schema registry means starting schema registry, you are saying?
Yes, you had that
It is there
schema
in.
registry.cmd.
Yeah. So
So
it's a same thing with the sh, right?
okay.
I'll
So
close that now, but command is coming from a Windows folder. There's a window. I'll show you here. Just hold on. So E and then Srikanth and this bin and Windows, right? So I'm using this command. Schema registry start, right? So instead of using this file, because you're running on a Linux, right? So directly go to the bin, right? Somewhere we have schema registry start.sh. Got it?
okay.
Okay. All right. Now something, we are done with the basic consumer and then producer. Okay. Couple of things are there, guys, but difficult to cover so many things in 24 hours. Okay, before I go to just thinking here. All right. Couple of things here, okay? I'll explain you a couple of things and then we'll take a okay, I'll give 2 options here. This is some trade-off now here, guys. You want me to go little deeper in consumer concept, or you want me to start with the streaming API?
Streaming.
Streaming? Okay. Yeah. What about others?
Streaming.
So in Stream API, you are covering that Java part, right? How Stream API like this, right?
Yeah, some example. Streaming is very big. Probably if you ask me like, how much time they require to cover complete streaming, probably 2.5 days, 2 to 3 days, right? But we don't have that much time. But I'll try to give a complete idea about the streaming API by giving you one good example. Is that fine with you?
What in consumer?
sorry, consumer, we have basically some properties, just like a producer properties we have seen, right? So that are not covered here. I was thinking to cover that, but I thought I'll check with you all. So properties are there, and then, you know, so when consumer is running, right, consumer has to request to the broker, right? When consumer is saying, so let's assume here, let me quickly cover that, okay? That's fine.
Yeah, sure.
So here we have one partition, right? So your offset is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? This is your partition 0, and producer guys are producing events to this, and consumer is consuming, right? So now we have instance of a consumer class. We say consumer dot poll and 100, right? If you remember the code, what happens here? Consumer make use of Bootstrap server, right? It's a 9092. Connect to that, get the information about the topic you're going to consume, let's say T1, and where are those partitions, right? And so it will connect to that partition wherever it is. It's this broker will give you information about that particular partition, and consumer will connect to the broker and request, hey, give me some events, right? So when I say some events, right, so there are some properties. Minimum fetch size, right? So if I say minimum fetch size is say 30K, right? So right now, if in your partition is only, let's say 20K data, right, it will not fetch. What is the minimum fetch size? You have to have 30K of data. So that 30K data, it will pull here. But if you do not have that 30K data, then it will wait. Then it will wait. So for waiting also, we have some properties, how long I should wait for the new data to come in. So that is also one property. I don't remember exactly the name of that property. Okay, right? So it will wait for it, and again it will try. So by that time, if you have a 20K, now it's total 40, right? So minimum fetch is what? 30K, right? So now, you know, minimum is 30K. So you have a 40K here, it will fetch the data, and then in a for loop, you will start processing the records. Okay, now when consumer is processing these records, okay, is the responsibility of consumer to keep track of what all messages, to keep track of what all messages are processed, what all messages are processed. Very, very important. It is the responsibility of consumer and not broker, guys. But consumer has to make use of broker. Why? Because consumer, here is your Kafka, right? These are the brokers. This is consumer, this is producer. They are not very much part of Kafka broker. They're the external clients. So when you are processing this, say 5 records, and something goes wrong, and you are trying to maintain this, what all messages you have consumed so far, if you are keeping at your level only, and if this crashes, so you do not have any information what messages you have consumed so far out of 5 messages. You will end up getting all the messages again, and you will end up reprocessing it, right? So it is the responsibility of, guys, focus here. It is the responsibility of consumer to let broker know that, hey, I am done with this particular offset. So let's say offset 0, 1, 2, 3, 4, right? So when I say commit this after processing 0, 1, 2, 3, 4, right? When this consumer is requesting broker to make a note of it, it is always the last process record, that is 4 plus 1. Okay. Now, assuming this particular consumer is reading the data from partition 0, and this is your partition 0. Okay. Now, Kafka, inside the Kafka broker, Kafka will make a note of it that topic T1, group GRP1, right? Partition 0 is consumed till the latest committed offset is 5. This information is stored at the Kafka broker, right? And where it stores in some internal topic called, what is the topic name? Anyone, those who are working on a Kafka? What is that internal topic name? It creates automatically. We don't need to create that topic. Anyone? If you go to the Kafka, if you go to the log, right, we have some internal topic, consumer offset 2, consumer offset 5, right? So all these consumers which are running, right, they are requesting broker to make a note of all this kind of a thing. So this information that for a topic T1, this particular consumer application from a partition 0 so far committed offset till 5. So even if this consumer goes down tomorrow, right? Even if this consumer goes down and you restart your consumer, and when you say start consumer.poll for topic T1, again, obviously this is the part of group GRP1, right? Kafka understand, oh, this particular group, this particular topic, and this particular partition, so far, these guys have consumed messages till offset 4. Right? So then when it gets a fetch request from the consumer, then it will give you, so this is process, this is process, this is process, this is process, right? This is process. And now Kafka, when you request as a new consumer, Kafka will give this new messages to you, right? So again, when you are done with the processing this, right, let's say this as a part of next poll, you get these messages again and for the new consumer here. Right? This is the new consumer, will process this record, and once it is done, then it will request broker to make a, to commit that particular offset. So that is happening at the broker level. Why broker level? Because when you store data at the broker level in some topic, right, we know that every topic has got a replication factor. Even if this data is stored on a one broker, that will be replicated on another broker, right? So that metadata is there. Okay, that's why you see this consumer offset, who all the consumers who are consuming, right, all these messages, right? So that information is there in this particular topics here, right? And by default there are 50 partitions are created for your consumer offsets. So if you go to the other broker where we have 147, if you go to the consumer 3, we have 03, right? So all the committed requests from the consumers coming for for certain offsets, right? So all this information is stored across all these 50 partitions. But right now there's only one replica here, right? But if you want in a real in a production environment, even for this topic consumer offset, you should have more number of replicas. Okay, so couple of things are there. So by default, okay, now let's assume here this is your Kafka cluster. These are the 3 brokers, and these are the 3 partitions. Okay, so as a part of consumer group, GRP1, you start a one consumer instance. Okay, and the topic you are reading here is a topic T1, right? So this is your topic T1, P0 leader, right? A P1 leader and P2 leader. Okay, guys, others are replica. Now producer are producing, and What will happen now here? C1 will consume the data from all three partitions, right? Yes or no?
Yes.
Okay. Now you are starting C2. What will happen? You are starting C2. What will happen?
One of the partitions will go to C2.
Correct. So right now, earlier, before you start C2 as a part of group 1, C1 was consuming P0, P1, P2. All right. Everything was going to the same. Right? The moment you add a new consumer in a consumer group, right, it triggers a rebalancing. It triggers a rebalancing. During rebalancing, right, no reading happens. Why? Because Kafka has to decide, since we got a new guy here, right, what C1 should consume, which topic is, which partition it should read, and what partition C2 will be reading, right? So some decision happens there, right? During that decision making thing, right? So it's a kind of a no processing happens here. No processing. I would say no processing. Right? So during rebalance, the moment you rebalancing will happen when you add a new consumer, right? When you remove or stop one consumer, right? Or when you add a new partition, to your topic. You alter the topic, right? And remove consumer, add consumer. So whenever you are doing this kind of a thing, right, this will trigger a rebalancing. Okay. So during rebalancing, whatever C1 was consuming, right, you need to focus here. Whatever C1 was consuming, right, that will be stopped for a while, right? Now C2 is there. Now Kafka will take a call. Okay, fine. C1 will continue reading the data from P0 and P1, and C2 will read the data from P2, right? You are adding one more consumer. What will happen? You are adding so this will trigger a rebalancing. Again, everything, right? Whatever you were doing, right, stop this. Now Kafka will take a call. Okay, fine. C1 will continue reading the data from P0, C2 will continue reading the data from P1, and C3 will read the data from P2. Okay. If you add one more C4, what will happen here?
That will stay idle.
Right. So obviously it will trigger a rebalancing, right? But immediately they will continue as it is. This will remain idle. Why we should have additional? Because if something C3 goes wrong, right? So I don't want that one consumer reading the data from two partitions. In case this C3 goes down, C4 will take care of a P2 here. So generally you should keep one idle instances of a consumer in your group. One clear?
Yes.
Okay. Any question here?
Just one thing on the metadata part, you said that it goes back to that offset topic.
Come again.
When once a message is consumed, there is an offset marking, right, in the underscore offset topic, the default topic.
Correct.
So where is it happening in the code? Like because we are subscribing it and polling, right? Just
yeah,
in the
good
back
question,
end,
right?
yeah.
Yeah. So basically here, if you look at the consumer code, okay. Okay, so if you understand simple consumer, okay, so we are not using this line, right? If you remember, are we using this line in code?
No.
We are using this one, right?
Yes.
So the code we have written so far, it is making use of auto commit, right? And so when you are using auto commit, there are some problems there. So here, you know, by default, this property is true. Okay. So what happens here? So every 100 milliseconds, you are going to poll the data, and every 1000 millisecond, it will commit. I2 commit interval config. Every 1000 millisecond, it will commit. It will not check whether whatever the things you have fetched so far, are you done with the processing all the records? No, it won't check. It will simply look at the timer. The moment it becomes the 1000, commit. Right? So in that, because of that issue, right, this auto commit kind of a thing, right, you might end up reprocessing some records, you might end up losing some records. Okay, so right, so this is something happening here, right? So auto commit is something very fast. You are not worried about reprocessing or losing some messages. Just like a fire and forget, your ultimate goal is to have a good, nice, and excellent throughput, right? So something very similar, right? But if you're worried about this, that you are not able to commit things properly, right, then we have a concept of a commit, synchronous commit, right? I told you the concepts are same, just like a producer, right? Now what is happening here? The moment you are done, now you are fetching here, right? Let's say you have fetch, offset 1 2 3 4 5 6 7 8 9, right? You fetch, you got all these messages with these offsets. One by one you are processing it, and once you are done with the processing, then you are coming out, and here itself you are saying hello commit. What is happening here? Here you are asking broker to make a note of what all messages I have consumed, right? So the last messages I consume is 99. So Kafka broker, for this particular group ID and then topic, it will mark that this guy has processed 99. The next committed offset is 1100.
So
Right?
while I'm consuming my processing the data, right? And for any reason the consumer breaks before the commit sync happens. So still the offset is set to the last one, right? The whatever was the last sync.
You have not reached to this, right?
Yeah. So that way I can control. Maybe this somewhat answers my question. I have not processed and all that, right?
Right. So here what will happen? You are not reached to the, you are not able to commit this, right? What will
Correct.
happen?
The offset
Obviously
still will be the
Kafka,
last one.
yeah, the,
Yep.
the committed offset is old one, not
Okay.
this one.
Got it.
So you will end up reprocessing this, right? So this is a safer option. If I use this before this, then it's a dangerous, right? You might
Correct.
lose some messages there.
Correct.
I think, I don't know who was asking that,
Yeah,
other day.
this is the okay. Understood.
So this is how we handle this, guys. Right, so see, I have some scenarios here. These are the properties. Okay, so these are the scenarios where you'll end up processing the records. Let me explain this and then I'll go to the streaming part. Hello. Okay, fine. Now see here. So these are the last committed offset. So this is basically, this is the last committed offset. This is committed, right? And here is a consumer dot poll every 100 millisecond, right? So you manage to get this as a part of one poll, all right? And as a part of another poll, you manage to get all these records, right? This is what you have at the consumer end, guys, okay? And successfully committed offset is 2. Basically, so that's why you are managed to get a messages 2 on 1, that is 3 4 5 6 as a part of one poll, and 7 7 8 9 10 as a part of next poll. All right, now we have one more property here. What is that? I2 commit interval, right? So now these events will be okay, fine. So events we are processing right now is this area, right? So right now you polled this messages, you polled this messages, you are done with the processing, right? And here you are about processing 10 and something went wrong. Okay. What will happen?
Offset 11 is missed.
Offset 11, right? So because, so maybe here before you commit, so there the auto commit interval was 1000 millisecond, and somewhere here, right, you were about to fire this commit. Before that, only something went wrong. What will happen here? You're still committed to offset is 2 only, right? So even if your process 3, 4, 5, 6, 7, 8, 9, you will end up reprocessing these records now. Got it? So these events will be reprocessed in case of a balancer. Balancing means what? Your consumer is crashed. That is as good as you're removing the consumer from your consumer group. So here we are reprocessing. Another use case, right?
But then when we are receiving messages, right, in your last code, we are processing one offset at a time, right, in a way, and we are committing each time.
No, we are going batch wise, right?
Okay.
So here I'm seeing poll, right? So I'm processing all the records from that batch, and at the end I'm committing here. Okay. So this is more safer than going this way, auto commit way, right? Because we cannot control this. Whenever that 1000 completes auto commit kind of a thing, right? So वो commit कर देगा. It will not check आपने कितना process किया है फिलहाल. But here we have a good control here at least.
Okay.
We are going batch by batch.
So now if in our file, like if you are mentioning the commit async commit command, then in this diagram, the offset will be set as at 11, right? 10.
In this example you are referring?
Yes.
Okay. So now here also, right? For example, after processing this, let's take an example of this here, right? So here, right? So you are saying this, you are not able to reach here, right? Something happened before that only?
Yes.
Yeah, obviously you will end up reprocessing this, right? But you can have a control here, right? It's only referring to one pole. Here you can have multiple poles in a auto commit, right? Here it's a auto committing happening here, this example. Right here we are controlling this. We have enabled set this property true false. By default it is true, right? So we have some control here, right? In this case I can keep on polling, right? So maybe I set my auto commit interval to 2000 milliseconds, right? So I'll have a lot of batches there and my processing is very heavy. I managed to poll 5-6 batches, right? But I'm here only and something went wrong. Or you're about to process the last message from all these polled batches and something went wrong. You'll end up reprocessing everything then again. Got it?
Okay.
Yeah. Now another use case here, right? So events we are processing right now is this, right? It is assumed that last committed offset is what? 2 here. Events written by the last pole is this. When you say last pole, right? Maybe as a one, this is a message you have polled here, right? This one. Right? So this is basically the last message of the, so when you say event written by the last pole, this is what you have written, right? 3, this is the last messages you have polled. And now you are here, 5th. And the time has reached to commit. So if you have polled 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, and then 12, right? So Kafka will look at the last offset from the polled messages. What is that? 12, right? It will commit 13. Right? But actually you are here only. Since it is time to commit, you are committed. What committed? Not 5. It looks at what is the last message from your poll? That is 12, right? It has no idea where you are currently. That's a different thread altogether. One thread is taking care of tick, 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 tick. The moment it is 1000, commit. One thread, thread 2, is going on processing one by one, right? So there's no connection between this. The moment this tick tick reaches to 1000, right, it will commit. What commit? What all message you have polled last time. That is 12, right? 12 plus 130. But actually, you know, thread 2 was processing this. All right. So since it is committed successfully and you process still only this, right? So when you restart, okay, so that time you will start processing from 13, 14, and this, right? You are losing these messages there. Right? These are the problems with your auto committing, right? And this is where we have certain semantics. That is something I'll show you in a streaming API. Streaming API will take care of all these kind of things there. So, right? So that's why, you know, we can use a synchronous commit again, you know. So synchronous commit is what? Synchronous. What was happening in a synchronous producer? Anyone remembers? What is the difference between synchronous producer and asynchronous producer? Who would like to answer?
It was waiting for the acknowledgement and was
Exactly.
slower.
Exactly, right? Here also, this guy is waiting for the acknowledgement from broker A. Have you committed this? Was this successful, right? If yes, then only it will poll another batch. Then only it will go for the next poll. Things are very slow but safe, right? So to avoid this slow thing, right, we can use commit asynchronous this way. This is another API we have. Okay, no difference there. All right, with this, we'll stop this, guys. Okay, let's focus on synchronous. So those are the things I'm explaining here, basically, nothing much. I'll be sharing that consumer document also for your reference. You can go through that. Any question?
Can we take break now?
You're hungry, right?
Not hungry, but feeling a bit sleepy.
I understand. Okay, so all right, fine. So let's do. Let's take a break here. Let's meet at 2 o'clock. All right, fine. Any question before going on a break here?
Yes, just one like generic no question. So we say that whenever we have consumed the message, but the messages are still like persisted on the disk, right? So it would not be available to the consumer group if it is already consumed, but it still persists, right? And as per
It
the
still persists and it is available for some other consumer applications with some other consumer group ID.
right. So
Right?
if and the retention policy is by default 7 days, right?
Yeah.
So once 7 days are done, then the message will automatically like gets deleted from the disk.
Correct.
Okay. So is there a way where we can check like what all messages are like present? Is there any like command where we can check?
Yeah. So basically, why you need to know this? Look at the from application point of view, right? So if, I mean, I understand your question, right? But then in reality, right, I'll check on this, right? So your question is, at any point in time, how to know what is the last offset? No, I would not say first offset, right? What is the last offset available in any particular partition? Is that your question?
Not maybe the last offset, but what all like messages are present on the disk at like any given time before it's it gets like deleted.
Yeah, I think we can check that, right? If you look at the consumer group.sh command, right? So there we can see what all offsets are available, right? that shows you current offset. That doesn't show you 1 to 100. That shows you 100, right? If you want the starting point as well, then I'll have to check. Right? But if you think from a application point of view, right? Are we really, looking for this kind of thing, because messages will keep coming and keep deleting, right? At any point in time. The moment it is 7 days old, things will be deleted.
Yeah,
So,
but like maybe
now
for
what is
analysis
the
purpose.
basically I mean, from where you're coming, basically, I'm not trying to relate that. Any use case like for this kind of
Yeah, like maybe for analysis purpose, right? If we are short of the storage, so maybe we sometimes we need to check whether what is this current size of the messages that is persisted on the Kafka. That
Okay,
might be
okay.
like one use
Yeah,
case.
there must be some metrics. There must be
Right.
some metrics. Okay. So you mean to say, as a part of some kind of a analysis, like,
Right.
so day wise, what all number of events we have, on what daily basis, what all events we are getting, and something like that, right?
Right.
Let me check. There should be some metrics basically. All right, fine. Check.
And so depend on analysis, like let's say we are short of some disk storage, so there might be some option to like flush that
See,
messages, right?
basically, it is not our headache. It is the responsibility of Kafka admin. Okay, so they have all those matrices. They are monitoring it, right? They are monitoring node by node where your storage has reached, right? Because you need to add more storage, right? You need to add more nodes in that situation. So Kafka admin will be handling kind of a things. And for those also we have a matrix available. Okay.
Okay.
All right, fine. See you at 2 o'clock then. Can we start, guys?
Yes.
Okay. Okay. Hope you are able to see my screen. Now, let me close this. I'll be sharing this project POS simulator. Okay. From day one, I was talking about some use case of store ID and then invoices and all this kind of things, right? So here is a small kind of a simulator which which will be generating a lot of invoices continuously, and that is something we can push it to Kafka. And on the other side, those who want to consume, they can consume. Okay, so it's a multi-threaded application. You can take this project. I'll be sharing with you. You know understand the Java part of it. I'll not get into that. It's a big thing. But yeah. So let me run here. Okay. Nothing is running. So let me start my Zookeeper and everything. Why I'm using this simulator? Because I'm going to use these events for my streaming API.
Shrikant, what we are doing?
Yeah, we are. I'm just explaining you some code here. Right. We are going to start with the streaming APIs.
Okay.
Okay, so looks like all the brokers are running. 1, 2, 3. All right. Okay. Now, I don't know whether topic is there or not. Earlier it was a Zookeeper, right? But now it's a Bootstrap server. Anyway, I'm using this older one, so I'll keep this as it is. Okay, so I would like to list here, right? So we don't need a topic name here. Okay. So only TXN is there. So let me create a topic here. So I'm creating a topic POS. Okay, and that's what we are referring in that simulator with the partition 3 and replication factor as 3. Okay, so let me comment this line and uncomment this. This is how we comment in a Windows. We put a remark there, right? So I'm creating a topic POS with the 3 partitions and 3 replication factors. Right, topic has been created, and now I am running a simulator. This is my simulator, which requires 3 command line arguments. One is your topic name, that is POS, then number of producers, since this is a multi-threaded, how many threads you want to run concurrently. So if I say 5, so 5 producers will be running continuously. Okay. And the produce speed, how much delay you want between the two events when one thread is running. Okay. So 3 parameters are required. Obviously, if I run, things will fail, saying, you need to provide all those things, command and arguments. Let's go to the run and the edit configuration and program arguments. First is a topic name. Second is the number of producers you're running. I'll go with the 1. And the speed between the two events, is, I'll say 500 milliseconds. So every half second, you will see the events are getting pushed to the generated. Okay. Apply and okay and run. All right. So my POS simulator is generating events, invoices, right? So let's go to the start consumer, which is consuming the message from topic POS from beginning. Let me run this. And here you can see the complex events here, right? And this will go on. So the delay here is a 5 seconds. Just imagine if I remove that delay, if I keep that delay as 0, and if I run a 10 producers, 10 threads for a 10 producer, provided I have 10 CPU cores here, so then you can see how many messages is coming into a Kafka at any point in time. Is a huge data, right? So
Shrikant, I'm so sorry to interrupt you. I didn't get, like, what is the need of this simulator? In simulator,
yeah,
are we just talking about scripts?
no. We see, basically, I'm just giving you some idea, and we are going to work on these events when I talk about the streaming API, right? So for that very reason, I'm just trying to give you idea, like, so this is the application which we are going to use for this kind of events here. This is the invoices.
Okay.
So what kind of data is it generating? Just give me 15 minutes, Tina. You will be clear what exactly I'm trying to explain you here. So this is basically a kind of a event we are generating. One is your invoice number, at what time your invoice is created, from which store this information is coming. You can have a multiple store, and every store has some store ID. POS, what is POS ID? Where you swipe your card, right? The person who is handling that POS, cashier ID, customer type, whether that customer there in the store is a prime customer or non-prime customer. Customer credit card number. If you want, you can use this card number. Okay, no worries. So total amount of a transaction, number of line items, only one order, one product here these guys have purchased, right? Payment method, taxable amount, GST, central GST, state GST, 6%, and delivery type. He want to take away, right? So no question of home delivery there, right? Invoice, as I told you, it's a array of line items. So how many items are there? 9 items for this particular invoice is only 1, right? So in this array, this is the array here, and this is the end of your JSON document, right? Let me take one more example here. So we need to have couple of line items here. So just give me 2 minutes. I'll not repeat now, I explained you. Now here delivery type is what? Delivery, home delivery, right? So obviously this one more object will come into picture, delivery address, and this is basically kind of another object, complex object here, right? So where we have this is one address line, okay, pin code and state and contact number, right? So this is the end of your address type basically, okay? And then 9 items. So how many line items you have purchased here? So 2, right? So in this array now, you will see 2 line items. One is this, and second is this, and this is the end of your array, and this is the end of your JSON document. Right? So this kind of data we are generating. Okay. Right? So you can always go and check the schema here now. Here is a complex schema, right? So if you look at this, you know, a delivery address is a field, right? But this field is not like a one field. It's a kind of object itself, right? If you look at this, delivery address is a kind of a object only. And this entire thing is also a kind of a object. So this POS invoice is the main class, is a kind of object. Within that, we have a sub object. For example, we have one for home delivery, right? Delivery type is equal to this. Home delivery, it's a type is object, and there'll be some fields here, you know. So address line, city, state, and credit contact number. That's what you see here, right? Similarly, right? So line items, it's an array. Line item is a array. Obviously, arrays of what? So item is of type some object, and what is that class name? Line item, which contains these properties: item code, item description, item price, item quantity, and total value. That's what you see here. Item code, item description, blah blah blah. Right? So you can take your example there, what I explained you to, you know, I ask you to do in the morning in the first half. So I say SID, S name, and then address, right? So instead of keeping address as plain Mumbai, right? What you can do here, you can try to add a kind of a sub object here. Increase this complexity, okay, step by step. All right, so basically we are going to use this example, okay? So let me stop my producer, otherwise it would be difficult to store those kind of messages. So I stop this, and now let's go to the, this part is clear basically, right? What this your event contains. Okay, after writing your JSON serializer, deserializer, right? I hope this will make more sense to you now. So this is what we are going to generate. And for a streaming API, we are going to consume these messages for all your use cases. Okay. Let me go back to my documentation. Okay. All right. Now, so Kafka streaming, there are many ways to create a stream processing application, right? So whatever the data events coming into Kafka, right? So we can use Kafka consumer API, we can use Kafka streaming API, we can use KSQL also, right? So as far as I'll not spend time here, as far as your processing is very simple, just take the record and dump it into some database. You don't need this high-end streaming API. You should be fine with the consumer API, right? But if you're planning to use some complex thing, you're planning to do some complex thing like maintaining the state between all the events and performing some aggregation. What do you mean by this? Anyone? Maintaining the state between all the events and performing some aggregation. What do you mean by this? Anyone?
So we are getting like from one topic, we are getting some kind of metadata, and then using that metadata, if we need to consume the respective data from another topic. So in that case, we need to maintain the state, and then for getting the entire result, we have to do aggregation also.
Okay. Yes. So anyone who would like to add here on top of this? Right. So this is the consumer, and here I say dot poll 100 milliseconds, right? So these are the messages you received, say M1, M2, M3, M4, right? What we're doing here, we are processing M1 done, M2 done, M3 done, right? Like this. But just imagine here we have C100. This is the first message. C1 200, second message. C1 300, third message. C1 400, right? So basically, we got a C100, 200, 300, and 400, right? This is one event, this is another event, right? So basically, if you want to maintain the state between events, across events, right? So, that is possible. So we call it basically a stateful streaming, right? And you are simply going record by record. You don't need to try, you don't need to maintain any state between the events, right? So if I ask you, like, for example, if I ask you, give me customer ID, customer wise sale, right? So you have to have maintained the state between all the customers at any point in time, right? So I would say, give me the customer wise sale for every 5 seconds or 5 minutes. So what are the events you have received in last 5 minutes? Maybe C1, 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 maybe C2, C2, C2. I would like to see C1. What is that? 100 plus 200 plus 300 plus 700, 700,000, right? C2, the total sum of those values. So this is basically kind of a stateful streaming, right? Now, if you are planning to do something like this is not a simple kind of thing, right? This requires a complex things, right? So then in that case, streaming API is more widely used than your consumer API. Consumer API is typically read the events, do some validation, and based on validation, do something, right? If this valid, do something, is not valid, do something, right? So no complexity involved here, right? But if you are saying that I would like to maintain this state between all the events, I would like to do the joining between the 2 or 3 or 5 topics, right? I would like to do some Windows based analysis. So this is one window of 5 seconds. This is another window, right? So what are the events are falling into that bracket of first 5 seconds, the next 5 seconds, then third 5 seconds, right? So what is happening in each window? So that is a Windows based analysis. Then fault tolerant. What if some consumers are failing, and then how we're going to handle it, right? So these are all complex things can be handled very efficiently by your streaming APIs, and people use streaming API for this. Either if you are planning to use a Kafka, its own streaming API, you can use that. Otherwise, you have option of Spark streaming or a Storm, right? It is up to you. As far as you are doing a super real-time processing, or Kafka streaming is recommended. If you say you are doing something near real time, you can use a third party like a Spark streaming or Storm or Flink, right? To do something near real time kind of a things. Obviously, it will take some time to pull the data from Kafka stack and get into the Spark and then process it. Okay. And another component, we have a KSQL, something like creating a table and then firing a queries on table. Creating a table like creating a when you say a table, right? You're referring a table where you have some records. Either you're inserting, either you're firing some queries to see some some data there, right? For some analysis, those kind of things. So here, like creating the topic is like creating the table and referring that topic, right? So this is also possible.
Shrikant, one question. So you mentioned 3 type of streamings, right? Like whenever we want to consume the data, then either we can use the Kafka consumer APIs, then Kafka streaming APIs, and then for very real time use cases, we can go for the Spark and other things. So this Kafka streaming API is nothing but this KSQL only, right?
No. So this is a different component altogether. Here we are firing like something SQL queries, KSQL. Instead of using the higher order functions and then Java API, right? You're firing a simple queries, just like SQL queries. So here it's a different thing altogether, right? Streaming API is another set of API. The way we have used, consumer API, we saw one example of consumer, right? So there we use all consumer API, consumer config, consumer API, right? It is completely a different set of API. So similarly, when you are using streaming API, right, we have another streaming API. We have a streaming, config class, which has some constant pertaining to the streaming thing. So this is one component, consumer is another component, and KSQL is another component, right? So typically, if you are planning to use Kafka with the kind of a kind of a micro services, right? So then preferred is a streaming API because it has its own server, it has its own client, right? You won't be able to fit this kind of if you're planning to use KSQL, right, for XYZ reason, right? So then you won't be able to fit this into a microservices architecture. You need to go with the streaming API here. Okay, fine. So yeah, now when it comes to Kafka streaming, there are four main components. Creating a configuration, that is creating the property class and then bootstrap servers and key serializer and deserializer and all those kind of a thing. Same thing here, right? But as a streaming API, another step we need to add here is a create stream topology. Slowly you'll understand, right? But for now, you remember configuration, topology. Basically, what is topology? When you start consuming the events in the first place, right? So here, when I say topology, forget about processing and starting, right? Topology means on those events, आपको क्या करना है? That's it. You plan very well, right? So once you start getting events from maybe one topic or 5 topic, right? What all things you are planning to do, that goes in a topology. Once your topology is ready, then you start the stream. What do you mean by start stream? They need to start reading the events, and on each event, what you have planned, what all things you want to execute as a part of, that will go on a topology. So configuration, create topology, आपको क्या क्या करना है on those events, that is a topology, and then start your streaming and add a shutdown hook. So it can handle in case if you shut down or your consumer, right? So gracefully there should be a proper closure of certain things, gracefully. So you're not stopping your consumer abruptly, okay, like that. So that will shutdown hook will take care of shutting down your consumer gracefully. So there are the 4 main components. All right, right? What is topology? Step-by-step computational logic of a stream processing application. As a stream processing application, when you start getting the events from some topic, we call it stream now, right? So when you start getting the events from a stream, what all things you want to do step-by-step computation, right? So maybe this is my one topic, this is my another topic, right? So here, first of all, I'm reading my transaction data. Here I'm reading the data from a consumer data, right? So here I'm joining these 2 data sets. So maybe some data is coming from a transaction data, some data is from a consumer data, right? And then further processing. Okay, so we need to build our topology first. Okay. Kafka stream application terminology. So here we have a stream is what? A sequence of immutable data records. What is coming from your topic is nothing but a stream of events, right? That fully ordered, can be replayed, and is fault tolerant. Think of a Kafka topic as a parent. What is basically stream is a sequence of immutable data records. When you start reading the data from your topic, right, as a consumer API, what you're getting basically a kind of a fully ordered events, right? And that we can process here. Then stream is the one thing, and stream processor, right? So what you see here in a blue colors, big circle, right? They are the processor. Okay, and the arrow you see here basically kind of a stream here. So stream processor is a node in the processor topology. It transforms the incoming stream record by record and may create a new stream from it. For example, right? So this is my source processor. Guys, be with me, okay? So this is your source processor. Source processor is not doing any transformation. Source processing is simply attached to one topic, and from that it's giving you some stream. So this is your stream, right? So this is your stream, this is also your stream. Now, for example, right? Let's go back to the example here. So this kind of events you are getting. This is your first event, let's say, right? Now, I would like to get the events where the city is Ganganagar from Rajasthan, right? So I'll apply, right? So I'll apply some processor. What is that processor? I'll say filter. I'm just giving example here, guys. Okay. So yeah, so this is the event you have. This is the event you are. So likewise, you'll come across all the events, one by one. So this is the event. Okay. This is one event, right? So this is your source processor. Right? Source processor will simply read the data from some topic. Okay. So here as a part of this, I would like to filter some records. So there are multiple processes like a filter, then map values, right? So if you have worked on a Scala language or some Lambda functions, right? So this is very common kind of a higher order functions. Okay. So here, this entire event is coming here, right? I'm checking on certain things. If the city is Ganganagar, then only that event will be part of this stream, right? This is a stream basically. This is also stream. So you won't get that. If I'm not looking for a Ganganagar, I'm looking for other than Ganganagar, right? So this event will not come, this event will not be part of a stream, right? So wherever you see other than Ganganagar, all those events will be part of this stream here. And then maybe I'm doing certain like joining here. This is another data set. This is the one topic A. This is topic B here, right? And then, so I'm joining here. After joining, I'm checking for a city. If it is the correct city, then that will be part of this stream here. And yeah, so from B side also, I'm doing some filtering over here, maybe, right? So here I'm looking for Ganganagar. Here also I'm looking for Ganganagar. This is maybe a transaction data. This is maybe a customer data. Okay. Right. So stream processor, these are all stream processors. Is a node in the processor topology, it transforms. So here, this will not do any transformation. I told you, this is a source processor, simply reading the data from the topic and pass on those stream of events to the processors downstream. These processes before the last one, they're all transformers. Maybe here it is joining, maybe here it is a transforming, is also kind of a joining, right? These are all a stream processor. They are transforming your incoming data from one form to another form. Remember, maybe it's a join, maybe it's a filtering, maybe it's a mapping, maybe adding some new fields. It can be anything. There are a lot of processes available. Any question here? Okay. Source processor, what you see on the beginning is a source processor. What you see at the bottom is the sink processor. So you start reading the data from these topics, right? You do some transformation, and at the end, you are getting some data, right? So that data you will push to some topic, right? A sink processor is a processor that does not have children at the bottom. It sends the stream data, whatever the stream of events coming here, right? This processor will take care of pushing those events to some topic. Okay, that is a sync processor. I already explained you source processor. Source processor will not get into transforming this data. It will pass on those events as it is. Okay. Now, there's a big case stream class there, and there are a lot of methods there. Mostly used is the abstraction of a stream of a Kafka message records. Here, when I say filter will return a new case stream. What is coming into filter processor, right, is immutable. You just take that, you work on it the way you want as per the business requirement, and create a new stream. So map, filter, flat map, all this processor will generate a new case stream. Okay, there are another set of methods like a for each or to, right? Here, have you worked on this kind of functions, guys, anytime? How many of you worked on this function? Lambda functions on a Python or Scala language. How many of you worked on this? Can I have a quick confirmation?
In Java, I have read about map, flat map, and for
Okay.
each filter.
Okay, very good. Anyone? Eh,
Yeah, use the filter and for each
Okay.
map.
Okay, so Ankur and Tina. Who else?
Yeah, to some extent I've used it.
Rilesh. Okay. Ravi.
I have used.
Cheryl. Okay, very good.
Hello.
So I see. Yeah, Ashutosh.
I have also used Ashish.
Ashish. Okay. Ashutosh, what about you?
Yeah, I've used it for
Okay,
Java.
very good.
and
Okay,
Reactive programming.
so I see most of you are comfortable with this kind of a thing, right? So it's a similar kind of thing. Okay, so so we have for each. Now for each is what, right? So let's say, for each, it's taking all the events from its stream, and for each event, maybe you're printing it. Maybe you are doing something else, right? But you're not returning the new, you're not doing any transformation. The return type for each is void. Okay. 2, I just trying to push all those events what is coming to processor. I'm pushing it to some topic, right? I'm not doing any transformation, right? So to and for each will not return anything. It's a return type is void. Okay. Now I'll be sharing this. I guess I already shared this, but if not, I'll be sharing this. So for a streaming type of application, what is all dependency you require, right? So everything is mentioned here. So maybe you can change the versions, latest version. So this is the old slide. So you can use this, right? And okay. Word count is, I'll take this later. Because, some count is coming into picture. So I not covered that. Okay. How to create your fat jar, right? So directly you can take that jar and without any, code, your dependency, right? We can run that code anywhere. So this is fine. Okay. Now, here is the thing now. Okay. We are going to work on these events now. And your key is a store ID. What is your store ID? What is your key? Your key is store ID. And there is some XYZ company, right? So use the PO simulator application to generate continuous stream of invoices. This is what your invoice is. Okay. And you're going to work on this, guys. Okay. So listen carefully. Create a stream processing application for the following requirement. What is the business requirement? XYZ is a home furniture and kitchen utensil retailer. They have 20 retail stores spread all over the country. XYZ management decided to transform themselves into a real-time data-driven organization. As the first step towards that, go, they started sending their invoices to Kafka cluster in a real time. Okay, the POS machines in all their stores are now sending invoices to Kafka topic POS. As the next step, they want to create the following automated services. One is shipment service, one is loyalty management service, and third is the trend analytics. Okay. So while other teams are working on the implementation details of these three services, you are asked to create a Kafka Stream application that does the following. For the first requirement, right? Select invoice where delivery type is home delivery. Now delivery type has two values, takeaway and home delivery. Whenever there is a home delivery, then push them to the shipment service queue. Okay. So we are getting some event and what is that field? Delivery type. Delivery type, right? So you are consumer, right? You got this event as an object. Object dot delivery type. If it is equal to home delivery, right? Then this complete object we are sending to another topic called shipping. It's a topic, right? So right now this object is a part of which topic? POS. So we are reading the data from topic POS, checking delivery type. If it is home delivery, then there is a separate team sitting outside and they are responsible for shipping those products to the customers. Okay? So complete object as it is will you need to send it to the shipping team. This is the first requirement. All right. So select invoices where delivery type is equal to home delivery, push them to the shipment service queue. This is a separate queue or topic, you can call it, right? So these guys are, simply taking events from this queue because they are simply responsible for shipping these products to those customers. This first requirement, right? Second requirement. Loyalty management services. Select invoices where the customer type is prime, right? So here the customer type is there. If it is prime, so they might have subscribed to some loyalty points. They have some credit cards, right? And we know we earn a lot of loyalty points on the credit card and such stuff like that, right? So if the delivery customer type is prime, create a notification event for the loyalty management services, right? Now we are not pushing that object as it is to the, here we are pushing that object as it is to the shipping team. It's okay, because shipping team needs to know the customer phone number because they might need to call them, right? Customer address. So here it is fine. But for a second requirement, we are taking that object as it is. You are taking here, same object I'm taking here, dot customer type. If it is prime, right, then create a notification, right? So basically in your object, you may be having around 20-30 fields, right? But for calculating loyalty points, do you need all this information, guys? Should we send this information to the loyalty team? What do you think?
No.
No, right? They have nothing to do with this. So we should restrict what they need, right? So incoming data to your processing is complete object and outgoing is what? Invoice number, maybe total amount, maybe card number, right? So based on that card, we can send some notification to that person that, hey, based on the purchase of 2169, you have earned 20 points, 30 points, 40 points, right? So there is a simple, some formula will be there and we will calculate and we will generate a new event now here, right? So in this case, based on this, if it's a prime, right, I'll take a transaction amount. I'll apply some formula there right? And then I'll create a one new event or new object based on what is required. We should send it to the another topic called a loyalty topic. We should not send all of the information to them, right? It's creating a new kind of a notification. Okay, so create a notification event for the loyalty management service. The format for the new notification event is given here, right? So if you go back, right? So let me stop this. It's already stopped. So here you go. Main resources schema. This is my invoice schema. Okay, complete in main object here, right? Delivery object is a object itself, right? Your line item is a array of objects. What is that object? A line item is a class, right? So when you are reading completely for a second requirement, what is the output? Notification events. What should go in a notification events? Only invoice number, customer card number, total amount of the transaction, and earn loyalty points, right? So basically this is what we are going to pass on to the loyalty topic here. Obviously somewhere we are going to do the transformation. What is coming here? 2000. What is coming here? Card number, right? But what is this? This is something we need to calculate, right? So we'll write some class and we'll do some transformation there. Well, that is something I'll show you later on. Okay, now this is the second requirement. Guys, are you with me?
Yes.
Yes. Yeah.
Okay. Third requirement. Select all invoices. Mask the personal information. Right? What is the third requirement? Trained analytics. Some data scientists people are going to analyze some data. We should not send them personal information, right? So mask them and then create a record for a trained analytics. Now, what is this requirement? When the records are ready, persist them to Hadoop storage for batch analytics. The format for the new Hadoop record is also given, right? So if you look at this Hadoop record, what we want here, we want invoice number, complete details, okay? Only, so here, this information will remain as it is. Do we have address here? I guess delivery type. We don't have, right? Yeah. So basically, something like this. Okay. Don't have space here. Okay. How many line items are there? 2, right? So this is the first line item, right? So from actually this is one event, right? But we'll split this into multiple events. So this is the first line item, right? This is the first one event from that main event. And similarly, I'll repeat this information, right? And what is the second line item? Second line item is this basically. Okay, right? So actually I'm reading one invoice here. This is what I'm getting there. Right? This is what I'm getting here. But so this is what data scientists or trained analytics want. They want the complete information, okay, plus the line item. They want to flatten this line items. So if there are 4 products, right? So they would like to have 1, 2, 3, and 4 records separately, right? So we are repeating this information basically, right? You understood what is the requirement? Third requirement here. right? So this is the invoice. One invoice can have one product, one invoice can have 10 products, right? So they would like to have these details along with, for each line item, they would like to have this information. So if you have an invoice, we have a 10 line item, right? They would like to get a 10 records there, right? So the line item 1, line item 2, line item 3, along with the common invoice related details that will repeat here, right? It's the same thing like this. That is the third requirement. Clear?
Yes.
Others?
Yeah, clear.
Okay, fine. Okay, so this is the requirement, and okay, yeah. So this is your first requirement. Read the data from your POS. This is your source processor. Will not get into transforming. This is the filter processor. We filter here for what? Only those customers where the home delivery is, sorry, delivery type is equal to home delivery. Those events will go to this topic. So it's not only POS. There are total 4 topics to be created for this application, for these 3 requirements, right? Second requirement, if the customer is prime, right, then do some transformation. Here you are getting 30 fields, right? But we are supposed to pass only 4 fields. So we are going to create some notification event, some complex object here. And those events will go to the loyalty points. We should not send all the information. Okay. Third requirement, get the complete POS as it is, mask your personal things. Okay. And then use some processor called a flat map values. I'll explain this later on, right? And then whatever the events you get here, so
Can you go back to the requirement diagram?
yeah, this one you are saying, or this one?
Yeah, this one. So this KS1, KS3, KS4, this is just a number, right? Which we are giving for those streaming.
Correct. So
streams.
basically, if you see here, right? So to begin with, I have a source processor, and this is your stream, right? We are calling this as a KS0. This is the stream, right? Then probably I'll apply a filter for a first requirement. Then probably I will use the same stream, right? KS0 here, and then my second requirement. So here also it's a filter. Here I'm checking for a delivery type. Here I'm checking for a prime customer, right? So we are going to use the same data here, right? And then so KS1 will have events where the delivery type is equal to home delivery only. So these are the streams here. You'll understand when I'll show you the code there. It's just the stream basically.
Okay.
Yeah. Any question here? Till now, everyone is clear?
Yes.
Okay. Fine. So if you look at your schema, right? So if you can see here, right? So this is how we define the schema here, right? So these are the 4 things here. One is your invoice, one is a line item, right? And we attach everything into a single schema there. You can refer that code. Okay. So from your POS invoice for a second requirement, if the customer is prime, then we are going to take a invoice number, card number, total amount from the original invoice, and then we are going to calculate on points. So this will go to the loyalty point. Okay. And from the last requirement, we are going to split your array, line item array. And for every invoice, if you got a 4 product in one invoice, right? We'll repeat this 4 times, this information for each line item. This is one line item, for one product ID, second product ID, those kind of things. Okay, fine. Now, I think you will require this code. I'll be sharing this code tomorrow. You'll get this. So okay, before this, right? So you understood the requirement. Now I'll take a simple example here, right? I'll take a simple example of a hello streaming, and then tomorrow we'll see, we'll try to write a code for this requirement. Okay. So maybe I'll help you with the first use case, right? And second and third you will try on your own. Okay. So let's understand the simple program using the streaming API. That is a streaming, hello streaming here. And okay. Now, so this is my apps config where I've defined some constant here instead of writing directly into the producer directly, these hardcoded kind of things. You can have some apps config. This is your one simple producer. This is fine. We are simply producing it, and this is your streaming application. Okay, fine. Now understand this. As a streaming application, we are using the streams config. Till now we were using producer config and consumer config, right? So now it's a streaming config. All of the things mostly will remain as it is. Okay. Now, so this part is clear. I guess this part is clear. Okay. Now, what is this? Default key surd. Okay. So default key surd, default value surd. All right. Now, typically, understand one thing here, right? So when you talk about streaming application, right? When you are talking about a streaming application, they are generally a consumer as well as producer, right? If you are not using streaming application, what we do here, we write a producer. And what you are producing? You are producing key as a string, value as a string. Yes or no? Right. When you write a consumer to consumer for the same topic, right? So what we say? We see key deserializer as a string deserializer and value as a deserializer, right? So in the producer, we have key serializer, value serializer, and here it's a key deserializer and value deserializer, right? But streaming application is typically a combination of both. Okay. Now, guys, focus here. Now, if you are planning to read string as a key and value, and you are planning to, consume as the same, right? String, right? So in that case, instead of writing like a 4 times, right? We can say our default key as string and default value as a string. Guys, are you with me? Because this is a string, this is a string. We are not changing in between, right? I'm reading this string and my output is also string, right? So here we can say default key is of type string, default value of type string, right? If you are sure what you are reading, the same thing you're going to pass on. Okay. Whether you are consuming as a string, when you are producing as a string. So in both the situations, it is the same. I will have these 2 lines, but if you are reading as a string and POS, okay, you are consuming store ID as a key and POS invoice as a value, but after processing, let's say second requirement, this is coming into your consumer, right? In the first place, as a part of streaming application, the first part you see is generally a consumer. You're consuming some data from some topic, and that topic is a POS. And what kind of a key you have? Key is store ID, and then value is your POS. As a part of a second requirement, are we sending this as it is? Are we sending store ID and then POS invoice as it is in a second requirement?
No.
No. What we are passing? A notification event, right? something different. So in that case, in my streaming application, I cannot say a default key and default value, right? I'll read as string and POS. And when it comes to send those events after processing to a loyalty topic, right? Then I would say I would like to send string as a store ID and notification event, not POS invoices, right? So your streaming application is typically combination of consumer and then produce, consumer and then produce, maybe consumer and push it to some database also, that is possibility. But typically it's a consuming and sending event further to some different topics. Okay, understand this. Okay. Then, right? So first thing comes is your stream builder. Typically, creating the instance of a class.
Shrikant, I have one question.
Yeah.
Can you please go back to that diagram? So previously, like when we were writing the producer, then we were mentioning the key serializer and the value serializer for our key and value. And similarly, we were mentioning for the deserializer as well, like at the consumer side. Now you're saying like if we are not using the consumer APIs, if we are going to use the streaming APIs, then considering both consumer and producer, we have to mention that stream config serializer and deserializer here.
Default, if you are sending the same type of data from a producer and consumer is also consuming the similar type of data, right? If you are not changing your types between what you are reading and what you are planning to send to some different producer as a producer to some topic, right? If there is no change in types of key value, right, then only you will go with the default key and then default value. So this is applicable to your consumer as well as your producer. We are instead of saying string and string, we are saying default key is a string and default value is also a string.
But suppose like if there is a change, then
yeah, so there is a change, then this won't come. This won't come. Then obviously this won't come, right? So when you say consume, first is basically you consume, right? So you will say consume with store ID and then POS. Consume, right? As a consumer, right? Your streaming application first as a consumer. So when you start consuming, I'll say consume with a key as a string, value as a POS invoice. And when you are done with the processing in between, I would say produce with. Now in produce with what? I'll produce key as a store ID and value as a notification event. So at every stage, what you are consuming, we are specifying what key and then value type is. And if you are planning to change the type, right? So then I'll say produce with key and then type. Then are you clear now?
Yeah.
Okay. So we'll see that example. This will be clear, right? Now, this is a very simple example. So we have this common kind of a thing, right? Otherwise, in a typical streaming application, this won't be the case, right? You always keep on transforming the events from one form to another. Obviously, your schema will change, in that particular path. So it doesn't make any sense. Okay. All right. So here, first thing is topology, right? So topology is what? Basically reading the data from some stream. Right? So here to create those streams, we use a stream builder. Now, typically, generally we create a class and we define the instance of that. We use that, right? For example, if you remember consumer, right? We created the consumer and that is the one instance of that consumer. I cannot use those created instances of that consumer as a separate application, right? So if you are planning to see, streaming API manages scalability also on their own. So why we have a stream builder? Why we are not creating the instance like the way we have created Kafka consumer and then Kafka producer, right? So here, once you build your topology, then under the hood, Kafka Streaming API can create multiple instances of that topology across instances automatically. You don't have to write a multi-threaded application like the way I showed you a POS simulator. Right? That is the beauty of a stream builder, right? If I create an object here, then this entire application will be running as a one single application. I cannot share, or I cannot run two instances using the same instance of that class. That is not possible. Okay. So for that reason, we have a concept of a stream builder, and I'm using the stream builder and I'm attaching a stream, and this stream is going to read the data from some topic here. Okay, topic name, and here this is your first kind of a source. This is your source processor, basically, you can say. And from that, the first stream you are getting is a KS0, right? And now, what kind of a key value you are expecting in that stream? That is something is a instance of a K stream. And here I'm going expecting integer and then string, something like this here from this topic here. Okay. All right, then I think it's okay. Let's stop here. It's already 3:02. We'll understand this. I'll run this for you, and then we'll be writing a code for this use case tomorrow. And I'll show other things then. Okay. So meanwhile, I'll share POS simulator with you, so you can generate event on your own, right? And I'll be sharing this example for your reference, and this example which covers all three. This example basically, where is that? Yeah.
Will you be sharing the requirement document?
Yeah, I'll be. I already shared the document, I guess, but I'll check, and if it is not there, I'll upload again. Fine. Okay. So, and plus these two as well, these two things for compatibility purpose. Multiple versions using the Avro serializer and deserializers. Okay. If you all free, if you do not have anything else, then probably we can continue for some time. Let me know.
We have meeting from 3:15.
Fine then. Fine. All right then. Thanks everyone. See you tomorrow at 10 o'clock.
Thank you.
Thank you. Thanks.
Thank you.
Thank you.
Thank you.